Hello everyone. Today we'll study factoring. Let's look at all example first. Let's look at all example first. How do we multiply this? 2x times 3x plus 4. When we multiply 2x to these parentheses, I multiply 2x to each term in the parentheses. I distribute 2x to each term in the parentheses. 2x times 3x squared is 6x to the power of 3. 2x times 4 is 8x. The operation from left to right, that's what we learned last class. Operation from left to right is called multiplication. Operation from left to right is called multiplication. If we try to go backward, that's called factorization. If we try to go backward, this operation is called factorization. So today we'll study how to do factoring. So for factoring, I will first of all show you taking out greatest common factors. First way to factor is called taking out common factors, greatest common factors. First way to do factoring is called taking out greatest common factor. That first method to factor is called taking out the greatest common factor. Taking out the greatest common factors. That's the first way to factor. That's the first method to factor. It's called taking out the greatest common factor. Greatest common factor is called the GCF. Greatest common factor is also called a GCF. First of all, let me introduce what's the GCF. GCF, greatest common factor of polynomial. Is the greatest common factor of the coefficients. The greatest common factor of the coefficients followed by the common letters, common variables. It's the greatest common factor of the coefficients followed by the common variables. Raised to the lowest power. Raised to the lowest power. Let me show you some example. Greatest common factor of a polynomial is the greatest common factor of the coefficients followed by the common variables raised to the lowest power. Let's look at some simple example first. Find the greatest common factor. First example. Suppose I give you 10 and 20. What's the greatest common factor? For 10 and 20, the greatest common factor is 10, because I can divide both numbers by 10 evenly. So the greatest common factor is 10. I can divide both numbers by 10 evenly. That's called the greatest common factor. If I give you A and 18. If I give you A and 18, what's the greatest common factor? I can divide both numbers by 2 evenly. Let's call the greatest common factor. I can divide both numbers by 2 evenly. For A and 18, I can divide both numbers by 2 evenly. So let's call the greatest common factor. X to the power 4 and x to the power 6. X to the power 4 and x to the power 6. The common letter is x. The common variable is x. And I choose the lowest power. Lowest power is 4. So x raised to the lowest power. Common letter is x. Lowest power is 4. Another example. Y to the power 2, y to the power 5, y to the power 3. If I give you 3 terms, what's the greatest common factor? Common letter is y. I choose the lowest power. Lowest power is y to the power of 2. Common letter is y. I choose the lowest power. Lowest power is 2. Next. Fifteen x to the power 4 and 10x squared y to the power 3. What's the greatest common factor? For 15 and 10, look at the number first. For 15 and 10, I can divide both numbers by 5. So 5 is the greatest common factor for 15 and 10. The largest possible number I can divide is 5. The largest possible number I can divide for both numbers. The largest possible number I can divide is 5. So 5 is the greatest common factor. Now, common letter here, they both contain letters. Common letter is x. Common letter is x. Common letter is x. I choose the lower power. Lower power is 2. Lowest power is 2. Common letter is x. I choose the lowest power. Y is not common. Y is not a common letter, so it doesn't count. Since y is not common, it doesn't count. Next. Negative 21 xy, comma 6y to the power of 4. What's the greatest common factor? When we are looking for the greatest common factor, we don't care about the sign. We don't care about it's positive or negative. When we are looking for the greatest common factor, we don't care about the sign. We don't care if it's positive or negative. Look at the number first. For 21 and 6, the largest possible number I can divide is 3. For 21 and 6, the largest number I'm allowed to divide is 6. Sorry. The largest number I'm allowed to divide is 3. I can't divide by 6. 21 divided by 6, I don't get whole number. If I use 21 divided by 6, I don't get whole number. When the largest number I'm allowed to divide is 3. That's the greatest common factor for the numbers. Now here, common letter here is y. And I choose the lowest power. Y by itself, power is 1. 1 is lower than 4. So I choose the lowest power. 3y to the power 1. For the final answer, if the power is 1, we don't write 1. So that's the greatest common factor. M squared n, 24 m to the power 5 n, and 18 m to the power 3 n to the power 2. What's the greatest common factor? Look at the number first. 12, 24, and 18. the largest possible number that I'm allowed to divide is 6. For all these three numbers, the largest number I'm allowed to divide is 6. 12 divided by 6 is a whole number. 24 divided by 6 is 4, that's a whole number. 18 divided by 6 is 3, that's also a whole number. So the largest number I'm allowed to divide is 6. That's the greatest common factor of the number. That's the greatest common factor of the coefficient. Then we pick the common letter raised to the lowest power. M is common. M is common. And choose common letter raised to the lowest power. Here, lowest power is power 2 for M, for letter M. Lowest power is power 2. Now, letter N is also common here. In this example, letter N is also common. Letter N is also common. Lowest power here is 1. M by itself power is 1. 1 is less than 2. So lowest power is 1. And if the power is 1, we don't write 1. So the final answer is 6m squared times n. Next. 28 to the power 3 b squared c, comma, negative 15 a b to the power 4, comma, 35 a to the power 5 b to the power 8 c to the power 4. What's the greatest common factor? Look at the numbers first. 20, 15, 35. When we look at the number, we don't care about the sign. When we find the greatest common factor, we don't care about the sign. Look at 20, 15, 35. The largest number that I'm allowed to divide. For all three numbers, the largest number I'm allowed to divide is 5. The largest number I'm allowed to divide is 5. 20 divided by 5 is 4. 15 divided by 5 is 3. 37 divided by 5 is 7. The largest number I'm allowed to divide is 5. Common letter is, letter A is common. Letter A is common. For letter A, lowest power is power 1. If there's no power, power is 1. And if the power is 1, we don't write 1. Lowest power is power 1, we don't write 1. We don't write power 1. Letter A is common. What else is common? Letter B is common. And for letter B, we choose the lowest power. For letter B, the lowest power is power 2. For letter B, lowest power is power 2. Anything else common? Letter C is not common because there's no C in the middle term. Letter C is not common, so it doesn't count. So we have common letter raised to the lowest power. We only use common letter raised to the lowest power. That's how we find the greatest common factor of a polynomial. We first of all find the greatest common factor from the numbers first. Then we find the common letter raised to the lowest power. We first of all find the greatest common factor from the numbers first. For 20, 15, 35, greatest common factor is 5 because that's the largest number that we are allowed to divide for these three numbers. Then pick the common letter. A is common, B is common. Then we choose common letter raised to the lowest power. For letter A, lowest power is power 1. For letter B, lowest power is power 2. That's how we find the greatest common factor. Next, I'll show you the first method of factoring. Factoring by taking out the greatest common factor. Next, I'll show you the first method of factoring. Factoring by taking out the greatest common factor. Look at first simple example first. Look at a simple example first. 25x to the power 6 plus 10x to the power 2. So when there are multiple terms and we try to factor in by taking out the greatest common factor, look at the numbers first. For 25 and 10, the largest number we are allowed to divide is 5. The largest number we are allowed to divide is 5. Then the common letter here is x. The common letter is x. We choose the lowest power. Lowest power is 2. Then let's first of all we write the greatest common factor in the front. Then put the rest in the parentheses. For the rest, 25 divided by 5 is 5. 25 divided by 5 is 5. First term, we have x to the power 6. That means there are 6x multiplied together. If I take out 2 of them, we have 4x left inside. X raised to power 6 means there are 6x multiplied together. If I take out 2 of them, that means there are 4 more stays inside the parentheses. Next term, 10 divided by 5 is 2. 10 divided by 5 is 2. 10x squared means we have 2x multiplied together. If I take out 2 of them, there's no x left. For x squared, if I take out x squared, there's nothing left. X squared means there are 2x multiplied together. If I take out 2 of them, there's nothing left. So second term becomes 2. That's how we factor in by taking out the common factor, the greatest common factor. Another example, 18n to the power 3 minus 6n. We first of all find the greatest common factor from the numbers. For 18 and 6, the largest number that I'm allowed to divide is 6. Common letter is letter n. Then we choose the lowest power, power 3 and power 1. If there's no power, assume the power is 1. For power 3 and power 1, the lowest power is power 1. So we have 6n, that's the greatest common factor. Next, 18 divided by 6 is 3. 18 divided by 6 is 3. N to the power 3 means there are 3 n's multiplied together. If I take out one of them, another 2 left here. 18 n to the power 3, that means there are 3 n's multiplied together. If I take out one of them, there are 2 more left inside. Second term, 6 divided by 6 is 1. There's only one n here. If I take out n, there's no letter left. So the second term is 1. That's the final answer. Next example, 21x to the power 3 minus 7x squared y. First of all, we find the common factor for 21 and 7. For 21 and 7, the largest number that I'm allowed to divide is 7. And then next, look at the common letter. The common letter is x. And lowest power for x is power 2. Then we try to take on a common factor. 21 divided by 7 is 3. X raised to power 3 means there are 3x. If I take out 2 of them, there's one more x left inside the parentheses. For the second term, 7 divided by 7 is 1. X squared means there are 2x multiplied together. If I take out 2x, there's no x left. There are 2x. If I take out x squared means I take out 2x, there's no x left. What's left is letter y. Now, for your final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. Next. 5x squared minus 7x to the power 5. 5x squared minus 7x to the power 5. For 5 and 7, what's the greatest common factor? For 5 and 7, the greatest common factor is 1. That's the largest number that I'm allowed to divide for both numbers. That's the largest number that I can divide. Then common letter is x. Lowest power is power 2. Now, if the coefficient is 1 for any term, if the coefficient is 1, we don't write 1. If the coefficient is 1, we don't write 1. Now, 5x squared, that means there are 2x multiplied together. If I take out x squared, there's no x left. What's left is number 5. Next term, 7 stays the same. X to the power 5 means there are 5x multiplied together. There are 5x multiplied together. If I take out 2 of them, there are 3 more x left. That's the final answer. Next example, 6x to the 6y to the power of 7 plus y to the power of 4. Take out common factor first. Since there's no number here, we don't take out common factor for numbers. Only look at the variables, the letters. Only look at the letters. Letter y is a common factor. The lowest power is power 4. First term, number 6 stays the same. Y to the power 7 means there are 7 y's multiplied together. If I take out 4 of them, there are 3 more left here. Second term, y to the power 4. That means there are 4 y's multiplied together. If I take out 4 y's, there's nothing left. But if there's nothing left, we cannot leave it blank. When we're doing factoring, if there's nothing left, we cannot leave it blank. We write number 1 as a placeholder. If there's nothing left, we cannot leave this place blank. We write number 1 here as a placeholder. Number 6. 18xy to the power 4 minus 2y minus 4x squared y. 18xy to the power 4 minus 2y minus 4x squared y. So take out a common factor. Look at the numbers 18, 2, and 4. The greatest common factor is 2. That's the largest number that I am allowed to divide for each numbers. That's the largest number that I'm allowed to divide. Common letter, x is not common. Y is common. Lowest power for letter y, lowest power is power 1. If there's no power, power is 1. So lowest for letter y, lowest power is power 1. If I pull out 2y, 18 divided by 2 is 9. Since I only pull out y, x stays there. Since I only pull out y, this x stays there. Y to the power 4 means there are 4 y's. If I pull out one of them, there are 3 more left. For the second term, 2 divided by 2 is 1. There's only one y. If I take out y, there's no y left. Last term, 4 divided by 2 is 2. Since I only take out y, x stays here. So x squared stays here. There's only one y. If I pull out y, there's no y left. So that's the final answer. Next. 15a squared b to the power 3 minus 20, a to the power 5, b to the power 4, plus 30, a to the power 3, b to the power 2. So, first of all, we find the common factor for the numbers 15, 20, 30. The common factor is 5. That's the largest number I'm allowed to divide for all three numbers. That's the largest number that I'm allowed to divide. Common letter, letter A is common. Letter A is common. For letter A, the lowest power is power 2. Another common letter is letter B. Letter B is also common. The lowest power for letter B is power 2. What's left here? Take 15 divided by 5 is 3. A to the power 2 means there are 2 a's. If I take out 2 a's, there's no a left. B to the power 3 means there are 3 b's. If I take out 2b, there's 1b left. Second term, 20 divided by 5 is 4. A to the power 5 means there are 5 a's. If I take out 2 of them, there are 3 more left. B to the power 4 means there are 4 b's multiplied together. If I take out 2 of them, there's another 2 left here. Next, 30 divided by 5 is 6. A to the power 3 means there are 3 a's multiplied together. If I take out 2 of them, there's 1 more left. B to the power 2 means there are 2 b's multiplied together. If I take out 2 of them, there's no b left. So that's an answer. Next, 7xy plus 49 x to the power 4 y to the power 3 minus 21y squared. 7xy plus 49 x to the power 4 y to the power 3 minus 21y squared. First of all, we take out the greatest common factor. For the numbers 7, 49, 21, the greatest common factor is 7. That's the largest number that I can divide. That's the largest number that I'm allowed to divide. Common letter, x is not common. There's no x in the last term. Only y is common. Lowest power is power 1. So pull out 7y. For the first term, 7 divided by 7 is 1. X stays there. Since I only take out y, x stays there. There's only 1y. If I take out 1y, there's no y left. Second term, 49 divided by 7 is 7. I take out 1y, so x to the power 4 stays the same. There are 3 y's here. There are 3 y multiplied together. If I take out one of them, there are 2 more left. Last term, 21 divided by 7 is 3. Y squared means there are 2 y's multiplied together. If I pull out one of them, another one left here. Now, for the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. So that's the final answer. Number 9. Negative 14xy minus 6y squared. Negative 14xy minus 6y squared. First of all, try to find the greatest common factor. For 14 and 6, the greatest common factor is 2. For 14 and 6, the greatest common factor is 2. That's the largest number I'm allowed to divide. For 14 and 6, number 2 is the largest number that I'm allowed to divide. Then common letter is y. Common letter is y. For letter y, lower power is power 1. Lower power is 1. So 2y is the common factor. 2y is the greatest common factor. Now, for factoring, there's a rule. It says, if the first term is negative, we must pull out negative sign. For factoring, there's a rule. It says, if the first term is negative, we must pull out negative sign. If the first term is negative, we must pull out negative sign. So I pull out negative 2y. Now, if I pull out negative 2y, negative 14 divided by negative 2, it becomes positive 7. Negative 14 divided by negative 2 is positive 7. If I pull out 1y, x stays there. Now for the second term, be very careful. We treat minus 6 as negative 6. We treat minus 6 as negative 6. Negative 6 divided by negative 2 is positive 3. Negative 6 divided by negative 2 is positive 3. Y squared means there are two y's multiplied together. If I pull out one of them, another one left here. So that's the final answer. Next. Negative 4x squared minus plus 4x minus 16x to the power 4. Negative 4x squared plus 4x minus 16 to the power of 4. First of all, we find a common factor for the numbers. For 4, 4, and 16, the greatest common factor is 4. That's the largest number that I'm allowed to divide for all these three terms. That's the largest number that I'm allowed to divide. So that's the greatest common factor. For letters, common letter here is x. So I pull out x. Then choose the lowest power. We have power 2, power 1, power 4. Lowest power is power 1. Now, for factoring, if the first term is negative, we need to pull out negative sign. If the first term is negative, we want to pull out negative sign. So for the first term, if I pull out negative 4x, negative 4 divided by negative 4 is positive 1. Negative 4 divided by negative 4 is positive 1. X squared means there are two x multiplied together. If I pull out one of them, the other one left here. Second term, if I pull out negative 4, I treat this as positive 4. I treat plus 4 as positive 4. Positive 4 divided by negative 4. Positive 4 divided by negative 4 is negative 1. Positive 4 divided by negative 4 is negative 1. That's only one x. If I pull out x, there's no x left here. That's the second term. Third term, I treat minus 16 as negative 16. For the third term, I treat minus 16 as negative 16. Negative 16 divided by negative 4 is positive 4. X raised to power 4 means there are 4x multiplied together. If I pull out one of them, we have 3x left. X to the power 4 means there are 4x multiplied together. If I pull out one of them, there are 3 more left here. Now, for the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. So 1x is the same as x. Next, 4x times 3x plus 2 minus 3 times 3x plus 2. Now, that's a little different. Observe these two parts. We can see that 3x plus 2 is a common factor. This part looks exactly the same. 3x plus 2 looks exactly the same. We can consider this is a common factor. We can consider this is a common factor. If I pull it outside, if I pull out 3x plus 2, what's left is 4x minus 3. If I pull out 3x plus 2, what's left is 4x minus 3. If I pull out what's common, what's left is 4x minus 3. That's a very special one. Next. 7a times x minus 2y plus 5 times x minus 2y. 7a times x minus 2y plus 5 times x minus 2y. If we observe these two parts, we can see that x minus 2y is a common factor. X minus 2y is a common factor. If I pull out x minus 2y, what's left is 7a plus 5. Next. Five y times x plus 3 minus x plus 3. 5y times x plus 3 minus x plus 3. If you observe these two terms, we can see that what's common is x plus 3. What's common is x plus 3. If I pull out x plus 3, if I pull out what's common, what's left is 5y minus, what's left is 5y minus what? From the first time I pull out x plus 3, what's left is 5y. Keep subtraction. From the second term, if I pull out x minus 3, if there's nothing left, I cannot leave it blank. I write 1 as a placeholder. If I take out x minus 3 and there's nothing left, I cannot leave this place blank. I write 1 here as a placeholder. We cannot leave this place blank. If we take out everything completely and there's nothing left, we write 1 as a placeholder. And that's the final answer. Next. 2x times x plus 4 minus 3 times x plus 4. If we observe these two terms, we can see that x plus 4 is a common factor. If I pull it outside, if I pull out x plus 4, what's left is 2x minus 3. That's the final answer. Next example. 4y squared times x squared plus 1 minus 2y times x squared plus 1. Four y squared times x squared plus 1 minus 2y times x squared plus 1. If we observe these two terms, we can see that x squared plus 1 looks exactly the same. X squared plus 1 looks exactly the same. We can pull it outside first. If I pull out x squared plus 1, what's left is 4y squared minus 2y. 4y squared minus 2y. Now, be very, very careful. Be very, very careful. Especially when you see some power other than 1. Be very, very careful. Look at the first term. X squared plus 1. Is there any common factor? There's x in the first term, but there's no x in the second term, so there's no common factor. In the first parenthesis, there's no common factor. We can leave it the way it is. In the second parenthesis, do you see common factors? I leave first parenthesis the way it is. In the second parenthesis, do you see any common factors? In the second parenthesis, do you see any common factors? 4x squared, 4y squared minus 2y. For number 4 and number 2, 2 is a common factor. 2 is a number that we are allowed to divide. 2 is the largest number that we are allowed to divide. Common letter is y. For y squared and y, common letter is y. Lowest power is power 1. If I pull out 2y, 4 divided by 2 is 2. For y squared, there are 2 y's multiplied together. If I pull out one of them, another y left here. Second term, 2 divided by 2 is 1. There's only one y. If I pull out y, there's nothing left. So for the final answer, I write this term in the front. Since this is outside the parenthesis, I put it in the front. Put it all the way to the front. This is outside the parenthesis. I put it all the way to the front. So for final answer, I write 2y s squared plus 1 times 2y minus 1. This is completely outside the parenthesis. I put everything outside the parenthesis all the way in the front. That's the final answer. Next. 6x squared times s plus 1 plus 3x to the power 4 times s plus 1. 6x squared times s plus 1 plus 3x to the power 4 times x plus 1. So first of all, we see that in both terms, s plus 1 is a common factor. S plus 1 is a common factor. I can first of all pull out s plus 1. If I pull out s plus 1, what's left is 6x squared plus 3x to the power 4. If I pull out s plus 1, what's left is 6x squared plus 3x to the power 4. Now observe, do we have any other common factors? In the first parenthesis, s plus 1, there's no common factor. In the second parenthesis, since there's no common factor, I leave it the same. In the second parenthesis, 6x squared plus 3x to the power 4. Do you see any common factor here? For 6 and 3, the greatest common factor is 3. That's the largest number that I'm allowed to divide for both numbers. Do you see any common letter? S is common. And we choose the lowest power. For 2 and 4, lowest power is 2. Pull out 3x to the power 2. What's left is 6 divided by 3 is 2. S squared means there's only 2x. If I pull out s squared, if I pull out 2x, there's nothing left. S squared means there are 2x multiplied together. If I pull out s squared, no more x left. Second term, 3 divided by 3 is 1. X to the power 4 means there are 4x multiplied together. If I pull out 2 of them, there's another 2 left. Then for the final answer, we see that 3x squared, that's outside the parentheses. When we see something outside the parentheses, put it all the way to the front. When we see something outside the parentheses, put it all the way to the front. We have 3x squared. What's left is x plus 1 times 2 plus 1x squared. If the coefficient is 1, for any term, if the coefficient is 1, we don't write 1. We write 2 plus x squared. So that's the final answer. Next, 3y times a minus b plus 4 times b minus a. 3y times a minus b plus 4 times b minus a. Now these two terms, they look almost the same, but a little different. They look almost the same, but a little different. First term is a minus b. Second term is b minus a. What should we do? Now be very, very careful. Keep one thing in mind. A plus b is always the same as b plus a. For addition, if you switch order, it makes no difference. For addition, if you switch order, it makes no difference. But a minus b is not the same as b minus a. They are not the same. For subtraction, you can switch orders. For addition, if you switch order, it makes no difference. For subtraction, you can switch orders. Be very, very careful. For subtraction, you can switch orders. 10 minus 3 is 7. And what's 3 minus 10? 10 minus 3 is 7. What's 3 minus 10? We consider combining like terms. Positive 3, negative 10. Positive 3, negative 10. When we're adding two numbers with different sign, keep the sign from the number has larger magnitude. Here, negative 10 has larger magnitude. Keep negative sign. Then subtract the magnitude. 10 minus 3 is 7. Another example. 12 minus 6. It's 6. 12 minus 6 is 6. How about 6 minus 12? We can subtract directly. So we need to consider their like terms. Just try to combine like terms. Positive 6 and negative 12. We try to combine positive 6 and negative 12. When we combine two numbers with different sign, keep the sign from the number that has larger magnitude. Here, negative 12 has larger magnitude. Keep negative sign. Then subtract the magnitude. 12 minus 6 is 6. So we can see that for subtraction, if I switch order, value is the same, but the sign change. If I switch order 10 minus 3 and 3 minus 10, value is the same, but the sign changed. Value is the same, but the sign changed. So we know that a minus b is not the same as b minus a, but that equal a minus b equal to negative b minus a. If I switch order, the sign changed. If I switch order for subtraction, if I switch order, the sign changed. So keep this in mind. For subtraction, if I switch order, the sign changed. So for number 17, in the second part, if I switch order here, if I switch order, the sign changed. Positive 4 become negative 4. If I switch order, the sign changed. Positive 4 become negative 4. I leave the first term the same. Now we can see that a minus b is the common factor. Pull it outside. If I pull out a minus b, what's left is 3y minus 4. So be very careful. Next. X times x minus 9 minus 3 times 9 minus x. X times x minus 9 minus 3 times 9 minus x. What should we do here? We see that x minus 9 and 9 minus x, they look almost the same, but a little different. They have different order. If I switch order, the sign changed. For subtraction, if I switch order, the sign will be changed. So if I switch order, if I make 9 minus x to be x minus 9, the sign will be changed. Negative 3 become positive 3. If I switch order, the sign will be changed. I leave the first term the same. Then we see that x minus 9 is a common factor. I can pull it outside. X minus 9 is a common factor. I can pull it outside. If I pull out x minus 9, what's left is x plus 3. If I pull out x minus 9, what's left is x plus 3. Next example, 4x times x minus 1 minus 1 minus x. 4x times x minus 1 minus 1 minus x. If we compare these two terms, we can see that x minus 1 and 1 minus x, they are almost the same, but they have opposite orders. X minus 1, 1 minus x has opposite order. If I switch order, the sign will be changed. Negative sign become positive sign. I leave the first term, the first part the same. Then we can see that s minus 1 is a common factor. S minus 1 is a common factor. If I pull out s minus 1, what's left is 4x plus. 4x plus what? 4x plus. If there's nothing left, when I pull out common factor, if there's nothing left, we cannot leave it blank. We need to write 1 as a placeholder. If I take out common factor and there's nothing left, I cannot leave it blank. I must write 1 as a placeholder. That's the final answer. Next. (10a squared x minus 4 minus 6a 4 minus x. If I observe these two terms, x minus 4 and 4 minus x, they almost look the same. But x minus 4 and 4 minus x has different order. So if I switch order for a polynomial with subtraction in the middle, I need to change the sign. So negative 6a become positive 6a. I leave first term the same. Then I can pull out common factor. S minus 4 is common, I can pull it outside. Pull out S minus 4, what's left is 10a squared plus 6a. But be careful, we are not done. Be careful. For x minus 4, first part x minus 4, there's no common factor, I leave it the way it is. For the second term, 10a squared plus 6a. For 10 and 6, common factor is 2. Greatest common factor is 2. That's the largest number that I'm allowed to divide. For both numbers, that's the largest number I'm allowed to divide. Common letter is letter A, and choose the lowest power. Lowest power is 1. If I pull out 2a, 10 divided by 2 is 5. A squared means there are 2 a's. If I pull out one of them, another one left here. 6 divided by 2 is 3. There's only one a. If I pull out a, there's no a left. Then, since 2a is outside the parentheses, for the final answer, I put it in the front. 2a is outside the parentheses. For the final answer, I put it in the front. So the final answer, I have 2a. The final answer, 2a times x minus 4 times 5a plus 3. That's the final answer. Next example. xy minus 4x plus 3y minus 12. Do we see any common factors here? There's no common factor for numbers. For letters, x is not common. Y is also not common. So there's no common factor here. What should we do? When there are 4 terms, if I group the first 2 terms together and group the last 2 terms together, if I flatten the first 2 terms, what do we get? If I flatten the first 2 terms, I can pull out x. X is common factor. If I pull out x, what's left is y minus 4. That's the first 2 terms. For the last 2 terms, for 3y and 12, 3 is a common factor. I can pull out 3. Y is not common factor. I cannot pull out y. If I pull out 3, 3y divided by 3 is 1. Y stays the same. 12 divided by 3 is 4. And 1y is the same as y. Then we can see that y minus 4 looks exactly the same. For these two terms, y minus 4 looks exactly the same. If I pull out y minus 4, what's left is x plus 3. What's left is x plus 3. This technique is called factoring by grouping. This new technique is called factoring by grouping. Factoring by grouping. We group two terms together, group the first two terms together, and group the last two terms together. Factor each part individually, then combine together at the end. Another example. (4b minus 20 plus ab minus 5a). 4b minus 20 plus ab minus 5a. Again, if I look at these four terms, there are no common factors. So I can factor two of them at a time. We can factor two of them at a time. If I group the first two terms together and group the last two terms together, factor each part individually. For the first two terms, 4b minus 20, number 4 is the greatest common factor. 4 is the largest number that we are allowed to divide for 4 and 20. Then for the first term, 4b, 4 divided by 4 is 1. Letter b stays the same. Second term, 20 divided by 4 is 5. So we get 1b minus 5. If the coefficient is 1, we don't write 1. In general, if the coefficient is 1, we don't write 1. So we write b minus 5. Second half, ab minus 5b, we can see that a is the common letter. It's called common factor. If I pull out letter a, ab become b. If I pull out letter a, 5a become 5. Now we see that b minus 5 is a common factor. b minus 5 is a common factor. If I pull out b minus 5, what's left is 4 plus a. Another example, 6h minus 6k minus h squared plus hk. 6h minus 6k minus h squared plus hk. When we have four terms, we factor by grouping. When there are four terms, we factor by grouping. If I group the first two terms together, we can see that 6 is a common factor. Put it outside. If I pull out 6, I have h minus k. If I pull out 6, 6 divided by 6 is 1. 1h is the same as h. Second part, 6 divided by 6 is 1. 1k is the same as k. Second half. In the second half, we see that the first term is negative. In the second half, the first term is negative. Be very, very careful here. For h squared and h is the common factor. We choose the lowest power for h. H by itself, power is 1. So I pull out h to the power 1. For the second half, since the first term is negative, we pull out negative sign. H squared means there are two h multiplied together. If I pull out one of an h, I have h left. Now second term, we have positive hk. If I pull out negative h, positive divided by negative is negative. If I pull out negative h, positive divided by negative is negative. I pull out h, what's left is k. Then we see that h minus k is a common factor. If I pull out h minus k, what's left is 6 minus h. Next example. X to the power 3 plus x squared plus x plus 1. So if there are 4 terms, we group 2 of them together. We group the first 2 terms together, and we group the last 2 terms together. For the first 2 terms, if I try to factor the first 2 terms, x to the power 3 plus x squared, common factor is x. I choose the lowest power. For x to the power 3 and x squared, lowest power is power 2. If I pull out x squared, x cubed means there are 3x multiplied together. If I pull out 2 of them, there's 1 more x left here. Second half, x squared means there are 2x multiplied together. If I pull out x squared, I pull out x completely, nothing left. If there's nothing left, we cannot leave it blank. When we're doing factoring, if there's nothing left after factoring, we cannot leave it blank. X plus, we cannot leave this place blank. We write 1 as a placeholder. For the second half, x plus 1, there's no common factor. X plus 1, there's no common factor. So I leave it the way it is. When we see x plus 1, there's no common factor. We leave it the way it is. Then we see that x plus 1 is a common factor. x plus 1 is a common factor, I can pull it outside. If I pull out x plus 1, what's left is x squared plus something. You cannot leave it blank. Write 1 as a placeholder. You cannot leave it blank. If I pull out x plus 1, I cannot leave it blank. Write 1 as a placeholder. That's the final answer. Next. Phi y minus phi z minus y squared plus yz. Phi y minus phi z minus y squared plus yz. When there are 4 terms, we factor 2 of them at a time. Group the first 2 terms together and group last 2 terms together. For the first 2 terms, phi is the common factor. If I pull out 5, what's left is y minus z. For the second half, delta y is common factor. If the first term is negative, if the leading term from the second half, if the leading term is negative, we need to pull out negative sign. So pull out negative sign. Y squared means there are 2 y's multiplied together. If I pull out one of them, the other one left. For positive y, if I pull out negative sign, positive sign plus positive sign divided by negative sign is negative. If you want to pull out positive sign, if you want to pull out negative sign, positive divided by negative is negative. I pull out y. If I pull out y, there's a z left. Then we can see that y minus z is a common factor. Y minus z is a common factor. If I pull out y minus z, what's left is phi minus y. That's the final answer. Two xz plus ax plus 5yz plus 20y. 2xz plus ax plus 5yz plus 20y. When there are 4 terms, we factor 2 of them at a time. When there are 4 terms, factor 2 of them at a time. First 2 terms, 2xz plus ax. Take a common factor first. For number 2 and number 8, 2 is the common factor. 2 is the largest number that I'm allowed to divide. by both. I'm allowed to divide for both 2 and a. Letter x is common. Then what's left? If I pull out 2x, what's left here? 2 divided by 2 is 1. There's only 1x. If I pull it outside, there's no x left. Letter z stays. Second term, a divided by 2 is 4. There's only 1x. If I pull out x, there's nothing left. And for the final answer here, if the coefficient is 1, we don't write 1. So 1z is the same as z. For the second half, take out common factor. Look at 5 and 20. For number 5 and number 20, the greatest common factor is 5. That's the largest number that I'm allowed to divide for both numbers. And letter y is a common letter. If I pull out 5y, what's left here? 5 divided by 5 is 1. I pull out letter y. Letter z stays. And 1z is the same as z. If the coefficient is 1, we don't write 1. Plus 20 divided by 5 is 4. There's only 1y. If I pull out y, nothing left. Then we can see that z plus 4 is a common factor. If I pull out z plus 4, what's left is 2x plus 5y. If I pull out z plus 4, what's left is 2x plus 5y. Next example, 3ab plus 9a plus 4bc plus 12c. 3ab plus 9a plus 4bc plus 12c. When there are 4 terms, we try to group 2 of them together and factor each of them individually. 3ab plus 9a plus 4bc plus 12c. For the first 2 terms, take out common factor. For 3 and 9, the greatest common factor is 3. That's the largest number I'm allowed to divide for both numbers. Common letter is letter A. For the first term, 3 divided by 3 is 1. I pull out letter A, there's no letter A left. Letter B stays. For the second term, 9 divided by 3 is 3. I pull out letter A, there's no A left. So I get 1b plus 3. 1b is the same as b. If coefficient is 1, we don't write 1. Second half, 4bc plus 12c. First of all, take out common factor for 4 and 12 first. For number 4 and number 12, the greatest common factor is 4. And letter C is a common letter, common variable. Letter C is the common variable. If I pull out 4c, 4 divided by 4 is 1. Letter B stays the way it is. I pull out c, there's no c left. 12 divided by 4 is 3. I pull out letter c, there's no letter c left. And we know that 1b is the same as b. Then we can see that b plus 3 is a common factor. B plus 3 is a common factor. If I pull out b plus 3, what's left is 3a plus 4c. If I pull out b plus 3, what's left is 3a plus 4c. Next example, 6x squared plus 2x minus 9x plus minus 3. 6x squared plus 2x minus 9x minus 3. When there are 4 terms, I can factor two of them at a time. When there are 4 terms, I can factor two of them at a time. 6x squared plus 2x, take out common factor here. For 6 and 2, the greatest common factor is 2. That's the largest number we're allowed to divide for both numbers. Common letter is x. Lowest power is power 1. If I pull out 2x, what's left here? 6 divided by 2 is 3. S squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Second term, 2 divided by 2 is 1. There's only one x. If I pull out x, there's no x left. So you get 2x times 3x plus 1. For the second half, take out common factor first. For 9 and 3, the common factor is 3. If the first term is negative, if the leading term is negative, we need to pull out negative sign. If the leading term is negative, we need to pull out negative sign. Negative 9 divided by negative 3 is positive 3. Negative 9 divided by negative 3 is positive 3. X stays the way it is. Second term, negative 3 divided by negative 3 is positive 1. Now we can see that 3x plus 1 is a common factor. 3x plus 1 is a common factor. So I can pull out 3x plus 1. If I pull out 3x plus 1, what's left is 2x minus 3. That's the final answer. Next, 2x squared plus 5x minus 6x minus 15. When there are 4 terms, we factor 2 of them at a time. When there are 4 terms, we factor 2 of them at a time. For 2x squared plus 5x, pull out common factor. For 2 and 5, for number 2 and number 5, the greatest common factor is 1. For x and common letter is x. For x squared and x, common letter is x. Then we choose the lowest power. Lowest power is power 1. If I pull out 1x, when the coefficient is 1, we don't write 1. If I pull out 1x, when the coefficient is 1, we don't write 1. So only pull out x. For 2x squared, 2 stays the same. S squared means there are 2x multiplied together. If I pull out one of them, the other one left here. For 5x, if I pull out x, number 5 stays there. Now for the second half, take out common factor for 6 and 15. For 6 and 15, common factor is 3. For 6 and 15, common factor is 3. If the first one is negative, if the leading term is negative, we must pull out negative sign. If the leading term is negative, we must pull out negative sign. Then what's left here? Negative 6 divided by negative 3 is positive 2. Letter x stays the same. Negative 15 divided by negative 3 is positive 5. Now we can see that 2x plus 4 is a common factor. I can pull it outside. If I pull out 2x plus 5, what's left is x minus 3. That's the final answer. Next, 6x squared minus 3x minus 2x plus 1. 6x squared minus 3x minus 2x plus 1. When there are 4 terms, we group 2 of them together. We do 2 of them at a time. When there are 4 terms, we factor 2 of them at a time. For 6x squared minus 3x, take out common factor first. For 6 and 3, common factor is 3. That's the largest number we are allowed to divide for both numbers. Common letter is x. And lowest power, with power 2, power 1. Lowest power is power 1. If I pull out 3x, 6 divided by 3 is 2. S squared means there are 2x. If I pull out one of them, the other one stays here. 3 divided by 3 is 1. There's only 1x. If I pull out x, there's nothing left. For the second half, find common factor for 2 and 1 first. For number 2 and number 1, the common factor is 1. That's the largest number. We're allowed to divide for both numbers. When the leading term is negative, pull out negative sign. When the leading term is negative, pull out negative sign. Then 2 divided by 1 is 2. X stays the same. Positive 1 divided by negative 1. From the second term, positive 1 divided by negative 1 is negative 1. Then we can see that 2x minus 1 is a common factor. 2x minus 1 is a common factor. If I pull out 2x minus 1, what's left is 3x minus 1. That's the final answer. Next, I'll show you a simpler case for factoring. Factoring trinomials. With no leading coefficient. Factoring trinomials with no leading coefficients. Trinomial is a polynomial of 3 terms. Trinomial is a polynomial that has 3 terms. So factoring trinomials with no leading coefficient. That's a simpler case. Let me show you here. It's a simpler case. Trinomial with no leading coefficient looks like this. Looks like, for example, looks like this. X squared plus bx plus c. That's called trinomial with no leading coefficient. Or we say leading coefficient is 1. That's a trinomial with no leading coefficient. Let's look at a simple example first. X squared plus 7x plus 10. X squared plus 7x plus 10. That's a very, very simple case. X squared plus 7x plus 10. When we see a trinomial with no leading coefficient, we first of all draw 2 premises. Draw 2 premises first. First of all, split x squared. Split x squared. X squared can be split as x times x. X squared can be split as x times x. Next, find 2 numbers. Find 2 numbers that they multiply to be 10. Find 2 numbers. When you multiply, they give you 10. When you add, they give you 7. Find 2 numbers. When you multiply, they give you 10. When you add, they give you 7. It looks like the only possibility is positive 2 and positive 5. When you multiply, they give you 10. When you add, they give you 7. So find 2 numbers. When you multiply, they give you 10. When you add, they give you 7. Then, next, put these 2 numbers in the parentheses. That's it. That's the final answer. Next example. X squared plus 5x plus 4. X squared plus 5x plus 4. First of all, draw 2 parentheses. When you see a trinomial with no leading coefficient, draw 2 parentheses. Split x squared evenly. Split x squared evenly. X squared can be split as x times x. Next, find 2 numbers. Find 2 numbers. When you multiply, they give you 4. Find 2 numbers. When you multiply, they give you 4. When you add, they give you 5. Find 2 numbers. When you multiply, they give you 4. When you add, they give you 5. The only possibility is 1 and 4. Positive 1 and positive 4. When you multiply, they give you 4. When you add, they give you 5. That's the final answer. Next, x squared minus 10x plus 16. X squared minus 10x plus 16. First of all, split x squared. Write 1x on each parenthesis. X squared can be split as x times x. Next, find two numbers. When you multiply, they give you 16. When you add, they give you negative 10. Find two numbers. When you multiply, they give you 16. When you add, they give you negative 10. The only possibility here, we can try 2 and 8. 2 times 8 is 16. But we're going to get negative 10 here. So I can make negative 2 and negative 8. Negative 2 times negative 8 is positive 16. Negative 2 times negative 2 plus negative 8 is negative 10. Negative 2 plus negative 8 is negative 10. Put in the parentheses. Negative 2, negative 8. Next example. X squared minus 9x plus 20. X squared minus 9x plus 20. So, draw two parentheses. Split x squared evenly. Put x in the parentheses. X times x. Next, find two numbers. When you multiply, they give you 20. When you add, they give you negative 9. Find two numbers. When you multiply, they give you 20. When you add, they give you 9. The only possibility here is 4 and 5. 4 times 5 is 20. But 4 plus 5 is positive 9. If you want to get negative 9 here, I make negative 4 and negative 5. Negative 4 times negative 5 is positive 20. Negative 4 plus negative 5 is negative 9. That's the final answer. Next, x squared minus 4x minus 12. X squared minus 4x minus 12. Draw two parentheses. Split x squared evenly. X times x. Find two numbers. When you multiply, they give you negative 12. When you add, they give you negative 4. 12 can be factored as 1 times 12, 2 times 6, 3 times 4. 12 can be factored as 1 times 12, 2 times 6, 3 times 4. The only possibility to get 4 is we use 6 minus 2. The only possibility to get 4, the only way to get 4 is I use 6 minus 2. So for negative 12, I can try to make, I need to use 2 and 6. I need to make 2 positive, 6 negative. Then 2 positive 2 plus negative 6 will be negative 4. Positive 2 times negative 6 is negative 12. So put negative 2 in the parentheses, put positive 2 in the parentheses, negative 2 in the second parentheses. We find two numbers. When we multiply, we get negative 12. When we add, we get negative 4. Next, x squared minus 8x plus 15. X squared minus 8x plus 15. First of all, split x squared evenly. We have x times x. Then last term is 15. Find two numbers. When we multiply, we get 15. When we add, we get negative 8. The only possibility is 3 times 5. But 3 plus 5 is positive 8, not negative 8. So I need to make the sign. Negative 3, negative 5. When I multiply, I get positive 15. When I add, I get negative 8. Then put these two numbers in the parentheses. Negative 3, negative 5. That's the final answer. Next, x squared plus 2xy minus 3y squared. x squared plus 2xy minus 3y squared. Draw two parentheses. Split x squared, we have x times x. Now, if at the end, we have variables at the end. If there's variables at the end, we also split this letter. We also split y evenly. Y squared could be split as y times y. If there's letter at the end, we also split the letter at the end evenly. Y squared can be split as y times y. So split the variable in the front, split the variable in the end. Then do the same thing. Last coefficient is -3. We try to find two numbers that when we multiply, we get -3. When we add, we get +2. We try to find two numbers. When we multiply, we get -3. When we add, we get +2. For number 3, the only possibility is 1 times 3. That's the only possibility. So the only possibility for number 3 is 1 times 3. We try to get +2 here. So we can make -1, +3. -1 times +3. When we multiply, we get -3. When we add, we get +2. Then put these two numbers in the parentheses. -1, +3. For the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. Next, x to the power 4 minus 21x minus 46, 21x squared. X to the power 4 minus 21x squared minus 46. So when there's no leading coefficient, we split x to the power 4 evenly. X to the power 4 can be split as x squared times x squared. If I split x to the power 4 evenly, I have x squared times x squared. Last term is -46. I try to find two numbers. When I multiply, I get 46. I try to find two numbers. When I multiply, I get -46. When I add them, I get -3. For 46, the only possibilities is 1 times 46 or 2 times 23. And we know that 23 minus 2 is 21. 23 minus 2 is 21. So we can try to use 2 and 23. Since I try to obtain -21, I make +2, -23. Then -2 and +2 and -23. When I multiply, I get -46. When I add, I get -21. So put in the parentheses. That's the final answer. Next, x squared minus 5xy minus 14y squared. S squared minus 5sy minus 14s squared. So when we see trinomial with no leading coefficient, I draw two parentheses. Split s squared. S squared can be split as x times x. Then split y squared. Y squared can be split as y times y. The last coefficient is -14. We try to find two numbers that when we multiply, we get -14. When we add, we get -5. For number 14, the only possible factor is 1 times 14 or 2 times 7. And we know that 7 minus 2 can make 5 here. 7 minus 2 can make 5 here. So I try to use 2 and 7. Since I try to obtain -5 here, I try to use +2 and -7. +2 times -7 is -14. And +2 plus -7 is -5. Then I put these two numbers in the parentheses. +2, -7. That's the final answer. Next, x to the power 4 minus 5 x squared y minus 24 y squared. So when we see a trinomial with no leading coefficient, we draw two parentheses. Split x to the power 4 evenly. Split x to the power 4 evenly. I have x squared times x squared. Split y squared evenly. I have y times y. The last coefficient is negative 24. I try to find two numbers. When I multiply, I get negative 24. When I add, I get negative 5. I try to find two numbers. When I multiply, I get negative 24. When I add, I get negative 5. I can try to use positive 3 and negative 8. When I multiply, I get negative 24. When I add, I get negative 5. There's a lot of trial and error. You have to try it out. There's a lot of trial and error. Getting these two numbers, there's a lot of trial and error. You have to try it out. 24, I can try 12, 1 times 24, 2 times 12, 3 times 8, 4 times 6. The only possibility to get 5 is a minus 3. There's a lot of trial and error. You have to try it out. Then I make positive 3, negative 8. When I multiply, I get negative 24. When I add, I get negative 5. Put these two numbers in the parentheses. I get positive 3, negative 8. That's the final answer. Next, x to the power 6 plus 10x to the power 3 minus 24. X to the power 6 plus 10x to the power 3 minus 24. When it's a trinomial with no leading coefficient, we draw two parentheses. Split x to the power 6 evenly. I can make x to the power 3, x to the power 3. If I split x to the power 6 evenly, I can make x to the power 3 and x to the power 3. Last coefficient is negative 24. I try to find two numbers. When I multiply, I get negative 24. When I add, I get negative 10. For 24, there's a lot of trial and error. 12 minus 2 is 10. I try to use 2 and 12. In order to make positive 10 here, I can make negative 12, negative 2, positive 12. Negative 2 times positive 12 is negative 24. Negative 2 plus positive 12 is positive 10. So I can use negative 2 and positive 12. That's the final answer. Next, x squared minus 6x plus 48. X squared minus 6x plus 48. Draw two parentheses. Split x squared. I have x times x. Then next I try to find two numbers. When I multiply, I get 48. When I add, I get negative 6. For 48, you have to try very, very hard. 48, you can try 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't go to 48 evenly, 6 times 8. That's all possibility for 48. Now in all these cases here, 1 plus 48 and 48 plus 1, 48 minus 1, we don't get 6. 24 plus 2, 24 minus 2, we don't get 6. 16 plus 3 or 16 minus 3, we don't get 6. 12 plus 4 or 12 minus 4, we don't get 6. 8 minus 6 or 8 plus 6, we don't get 6. So none of the cases works. So we can't find such numbers. We can find such numbers that multiply to be 48, add to be negative 6. That means this problem is not factorable. If it's not factorable, we say this is a prime polynomial. It's a prime polynomial. Or simply say it's a prime. If a polynomial is not factorable, we say this is a prime polynomial. Or we simply say it's a prime. What we just did is about factoring trinomials with no leading coefficients. It's in the form of s squared plus bx plus c. Next, let me show you how to factor trinomials with leading coefficients. And it's in the form of as squared plus bx plus c. So, factoring trinomials of the form ax squared plus bx plus c. Those trinomials has a leading coefficient. Now let me show you some examples first. 2x squared plus 5x minus 3. (2x squared plus 5x minus 3). First of all, this number 2 represents A, 5 represents B, negative 3 represents C. First step, we multiply A and C. First step, multiply A and C. Number 2 represents A, number 5 represents B, negative 3 represents C. First step, we multiply A and C. 2 times negative 3 is negative 6. Multiply AC first. Then we try to find two numbers that they multiply to be negative 6. They multiply to be AC, and they add to be B. B is 5. Next, multiply AC first. Next, we try to find two numbers. They multiply to be AC, and they add to be B. So we try to find two numbers. When I multiply, I get negative 6. When I add, I get positive 5. I can try to use negative 1 and positive 6. When I multiply, negative 1 times positive 6 is negative 6. Negative 1 plus positive 6 is positive 5. When I multiply, I get negative 6. When I add, I get positive 5. So find these two numbers first. Next, we keep the first term the same. Keep the last term the same. Rewrite the middle term. As this, using these two numbers. 5x can be rewrite as negative 1x plus 6x. I keep first term the same. Keep last term the same. Rewrite positive 5x as negative 1x and positive 6x. X stays the same. For the coefficient, I use negative 1 and positive 6. So we rewrite 5x in two terms. Now we have four terms. We can factor this by grouping. Now we have four terms. We can factor this by grouping. If I group the first two terms together and the last two terms together, then I can factor each part individually. For the first part, take out a common factor. For 2 and 1, the greatest common factor is 1. And also, common letter is x. We pick the lowest power. For letter x, lowest power is power 1. If the greatest common factor is 1x, when the coefficient is 1, usually we don't write 1. So 1x is the same as x. 1x is the same as x. From the first term, number 2 stays the same. S squared means they are 2x. S squared means they are 2x. They are 2x multiplied together. If I pull out one of them, the other one left here. Second term, negative 1 stays the same. If there's only 1x, I pull out x, there's nothing left. Second part, 6x minus 3. Take out common factor for 6 and 3. The greatest common factor for 6 and 3 is 3. That's the largest number we can divide for both numbers. What's left here? 6 divided by 3 is 2. X stays the same. 3 divided by 3 is 1. Now we can see that common factor is 2x minus 1. Pull out 2x minus 1. Pull out 2x minus 1. What's left is x plus 3. That's the final answer. So, when there is leading coefficient, we first of all multiply the first and the last. That's called A times C. Multiply the first and the last, I get negative 6. Next, I find two numbers that they multiply to be negative 6. They add to be 5. Find these two numbers, then replace the middle term using these two numbers. Replace the middle term using these two numbers. Keep the like term the same. Keep the variable the same. Replace the middle term using these two numbers. Keep the variable the same. Keep the letter the same. Negative 1x, positive 6x. Now we have 4 terms. When there are 4 terms, we can factor by grouping. This technique has a name. It's called AC method. This technique has a name. It's called the AC method. So this technique has a name. It's called the AC method. This technique has a name. It's called the AC method. Next. 2x squared minus 7x minus 4. When there is a leading coefficient, we first of all multiply AC. A times C. 2 times negative 4 is negative 8. Next, try to find two numbers that they multiply to be negative 8, add to be negative 7. Try to find two numbers that they multiply to be negative 8, add to be negative 7. We can try 1 and A. A minus 1 is 7. But we want negative 7 here. So I can make positive 1, negative 8. Positive 1, negative 8. When I multiply, I get negative 8. When I add, I get negative 7. So, next, I keep the first term the same. Keep the last term the same. Replace the middle term using these two numbers. So I write positive 1x negative ax. Letter stays the same. Using these two numbers as coefficient, letter stays the same. Now we have 4 terms. I can factor this by grouping. Now when there are 4 terms, we can factor this by grouping. Group the first 2 terms together and group the last 2 terms together. For the first 2 terms, take out the greatest common factor. For number 2 and 1, the greatest common factor is 1. Common letter is x. And for x, lowest power is 1 here, so I pull out power 1. When the power is 1, we don't write power 1. So greatest common factor is 1x. Usually, if the coefficient is 1, we don't write 1. 1x is the same as x. If I pull out x, number 2 stays the same. X squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Second term, if I pull out x, number 1 stays the same. Since there's only 1x, if I pull it outside, there's no more x. So factor the first 2 terms, I get x times 2x plus 1. Second half, find the common factor for a and 4. Greatest common factor for a and 4 is 4. That's the largest number we can divide for both numbers. When the leading term is negative, we pull out negative sign. So pull out negative 4. If I pull out negative 4, what's left here? Negative 8 divided by negative 4 is 2. Letter x stays the same. Second part, last part. Negative 4 divided by negative 4 is 1. So we have 4 times 2x plus 1. Here, 2x plus 1 looks exactly the same. So that's the common factor. I can pull it outside. If I pull out 2x plus 1, what's left is x minus 4. That's the final answer. Next, 3x squared plus 11x plus 10. When we see a trinomial, if there's a leading coefficient, we multiply the first and last together. 3 times 10 is 30. Next, try to find two numbers that they multiply to be 30, they add to be positive 11. We try to find two numbers that they multiply to be 30 and they add to be 11. We can try positive 5 and positive 6. When I multiply, I get positive 30. When I add a number, I get positive 11. So I leave the first term the same. Leave the last term the same. Rewrite the middle term using these two numbers. Rewrite the middle term using these two numbers. So I can use 5 and 6. I write 5x plus 6x. The variable is x. Using the same variable. Rewrite the middle term using these two numbers with the same variable. Now we have 4 terms. We can filter this by grouping. If I group the first half together, greatest common factor for 3 and 5 is 1. Greatest common factor for 3 and 5 is 1. That's the largest number we are allowed to divide for both numbers. Common letter is x. Common letter is x. I choose the lowest power. For x squared and x, lowest power is power 1. If the power is 1, we don't write 1. And also, if the coefficient is 1, we don't write 1. If the coefficient is 1, we don't write 1. So 1x is the same as x. If I pull out x, what's left here? Number 3 stays the same. X squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Plus 5x. Number 5 stays the same. There's only one x. If I pull out x, there's no more x left. That's the first half. Second half. For 6x and 10, greatest common factor for 6 and 10 is 2. That's the largest number we're allowed to divide for both numbers. For 6 and 10, that's the largest number we're allowed to divide. What's left here? 6 divided by 2 is 3. Letter x stays the same. Plus 10 divided by 2 is 5. That's the second half. Now we see that 3x plus 5 looks exactly the same. 3x plus 5 looks exactly the same. I can pull it outside. If I pull out 3x plus 5, what's left is x plus 2. That's the final answer. Next, 5x squared plus 14x plus a. When we see 3 terms, if there's a leading coefficient, we multiply the first and the last. That's called the AC method. If I multiply first and the last, 5 times a is 40. Next, try to find two numbers that they multiply to be 40 and they add to be 14. Find two numbers that they multiply to be 40, add to be 14. We can try 10 and 4. 10 times 4 is 40. 10 plus 4. 10 plus 4 is 14. And we can use positive 10, positive 14. Positive 10 times, is positive 10, positive 4. Positive 10 times positive 4 is 40. Positive 10 plus positive 4 is positive 14. Then we leave the first term the same, leave the last term the same. Rewrite the middle term using these two numbers. We use 10x plus 4x. The letter stays the same. Then factor by grouping. When there are 4 terms, I can factor by grouping. If I group the first 2 terms together, I can take out a common factor. For 5 and 10, the greatest common factor is 5. That's the largest number we are allowed to divide for both numbers. Common letter is x. Pull out x. What's left here? 5 divided by 5 is 1. X squared divided by x is x. Plus 10 divided by 4 is 2. This x means there's only one x. If I pull out x, there's no x left. So the final answer, 5x times 1x plus 2. And when the coefficient is 1, usually we don't write 1. 1x is the same as x. For the second half, 4x plus a. Take out the greatest common factor. For 4 and a, the greatest common factor is 4. That's the largest number we are allowed to divide for both numbers. First term, 4 divided by 4 is 1. X stays the same. Second term, a divided by 4 is 2. And when the coefficient is 1, usually we don't write 1. 1x is the same as x. Now you can see that s plus 2 is a common factor. S plus 2 is a common factor. I can pull it outside. If I pull out s plus 2, what's left is 5x plus 4. That's the final answer. Next, 15 minus 17x plus 4x squared. Now, when there's no x in the front, when there's no letter in the front, we can reverse an order. Run a term with a variable in the front. With a variable in the front. Reverse an order. Put 4x squared in the front. When there's no x in the first term, I can reverse an order. Put 4x squared in the front. Leave the middle term the same. Move 15 to the end. Next, we can multiply 4 and 15. 4 times 15 is 60. We try to find two numbers that may multiply to be 60, add to be negative 17. Find two numbers that may multiply to be 60, add to be negative 16. There's a lot of trial and error here. 60 can be rewritten as 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. That's all possibility for 60s. That's all possibility for 60. Which pair works? 3 times 20. 20 minus 3 is 17. Let's try. 3 and 20. I want to get negative 17 here, so I need to try positive 3, negative 20. Positive 3 plus negative 20 is negative 17. But when I add a number, positive 3 plus negative 20, I don't get positive 60, I get negative 60. When I multiply, I don't get positive 60, I get negative 60. So this pair doesn't work. This pair doesn't work. 3 and 20 doesn't work. When I multiply, I don't get 60, I don't get positive 60. So this pair doesn't work. Can we find a different pair that works? 4 and 15, I don't get 17. When I add and subtract, I don't get 17. 5 and 12. 5 plus 12 is 17. Let's try 5 and 12. Since I want to get negative 17, I can use negative 5, negative 12. Negative 5 plus negative 12 is negative 17. And negative 5 times negative 12, double negative is positive. So negative 5 and negative 12 works. Next, I can rewrite in the middle term. I leave first term the same, leave last term the same. I can rewrite in the middle term as negative 5 times x minus 12 times x. Negative 5 times x minus 12 times x. use these two numbers, -5, -12. Letter x stays the same. Now we have 4 terms. I can factor by grouping. Now I have 4 terms. Factor by grouping. For the first 2 terms, take out the greatest common factor. For 4x squared and 5x, the greatest common factor for 4 and 5 is 1. That's the largest number we are allowed to divide for both numbers. Common letter is x. Lowest power is power 1. And if the coefficient is 1, usually we don't write 1. If the coefficient is 1, usually we don't write 1. So 1x is the same as x. If I pull out x, number 4 stays the same. X squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Second term, number 5 stays the same. And there's only 1x. If I pull out x, there's no x left. That's the first half. Second half, take out the greatest common factor. For 12 and 15, the greatest common factor is 3. For 12 and 15, the greatest common factor is 3. Since the first term is negative, we must pull out -3. When the leading term is negative, we must pull out -3. Then what's left here? -12 divided by -3 is +4. Letter x stays the same. 15 divided by +15 divided by -3 is -5. +15 divided by -3 is -5. Now we can see that 4x minus 4 is a common factor. 4x minus 4 is a common factor. If I pull out 4x minus 5, what's left is x minus 3. That's the final answer. Next, 21 minus 25x plus 6x squared. minus 25x plus 6x squared. So in the first term here, there's no letter. In the first term, there's no letter. In this case, I need to switch the first term and last term. Put it in descending order. Write the term with the power first. So I can write 6x first. Keep middle term the same. Move 21 to the back. Then we multiply a and c. Multiply 6 and 21. Multiply 6 and 21. That's my AC. 6 times 21 is 126. We need to find two numbers that they multiply to be 126. They add to be -25. Let's try to write down all possibilities. 126, I can make 1 times 126. 2 times 63. 3 times 42. 4 doesn't work. 5 doesn't. 6. 6 times 21. 7. 7 times 18. 8 doesn't work. 9. 9 times 14. 10, 11, 10, 11, 12 doesn't work. Okay, that's it. So those are all possibilities. We can try to see which pair works. 121 and 126 and 1, I can never make 25. 63 and 2, I don't get 25. 42 and 3, when I add and subtract, I don't get 25. 6 and 21, when I add, I get 27. When I subtract, I get 15. I don't get 25. Doesn't work. 7 and 18, when I add, I get 25. So 7 and 18 works. Let's try 7 and 18. Since I want to get -25, I make -7, make -18. So negative 7 times negative 18, I get positive 126. Negative 7 plus negative 18, I get negative 25. So I leave first term the same, leave last term the same. Since negative 7 and negative 18 works, I rewrite the middle term as negative 7x minus 18x. I rewrite negative 25 as negative 7 and negative 18. Letter x stays the same. Now we get 4 terms. I can factor by grouping. For the first 2 terms, take out common factor. For 6 and 7, common factor is 1. Greatest common factor is 1. That's the largest number we are allowed to divide for 6 and 7. Common letter is x. And lowest power of x is power 1. When the coefficient is 1, we don't write 1. 1x is the same as x. Six x squared, if I pull out x, number 6 stays the same. X squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Next, number 7 stays the same. There's only one x. If I pull out x, there's no letter left. Second half, the last part. Negative 18x plus 21. For 18 and 21, greatest common factor is 3. That's the largest number we are allowed to divide for both number 18 and 21. Common letter, there's no common letter because there's no letter in the second term. There's no common letter. Since the first term is negative, we pull out negative sign. Then what's left here? Negative 18 divided by negative 3 is positive 6. Letter x stays the same. Positive 21 divided by negative 3 is negative 7. Now we see that 6x minus 7 looks exactly the same. 6x minus 7 looks exactly the same. I can pull it outside. Then what's left is x minus 3. That's the final answer. Next, 12y cubed minus 2y squared minus 2y. Now, number 7 is a little different. If you observe carefully, these 3 terms, they have common factors. Number 7, if you observe carefully, these 3 terms, they have common factors. For 12, 2 and 2, they have common factor 2. Now, when we're doing factoring, if they have common factor, you must pull out common factor first. If there is common factor, you must pull out common factor first. 2 is a common factor. 2 is the greatest common factor. That's the largest number I'm allowed to divide for all 3 numbers. Letter y is common. I choose the lowest power. Letter y is common. I choose the lowest power. Lowest power is power 1. If I pull out 2y, what's left is 12 divided by 2 is 6. Y cubed means there are 3 y's multiplied together. If I pull out one of them, the other 2 left here. Second term, 2 divided by 2 is 1. Y squared divided by y is y. Last term, negative 2 divided by 2 is 1. Keep negative sign. 2 divided by 2 is 1. There's only one y. If I pull out y, there's no y left. Now, this is in the form of ax squared plus bx plus c. What's inside is in the form of ax squared plus bx plus c. A, b, c. That's a trinomial with leading coefficient. That's a trinomial with leading coefficient. I can try to factor this. Multiply a and c. Multiply first by the last. 2y stays the same. Don't touch 2y anymore. Since I pulled it out already, don't touch 2y anymore. We can leave it later for now. Don't touch 2y anymore. Factor this. A times C, first times last, is negative 6. Find two numbers that may multiply to be negative 6. Add to be negative 1. Find two numbers that may multiply to be negative 6. Add to be the middle number, negative 1. For 6, the only possibility is 1 times 6, 2 times 3. The only way to get 1 is 3 minus 2. I can get 1. The only way to get 1 is 3 minus 2. So you can try 2 and 3. Since I try to get negative 1 here, I make positive 2, negative 3. I make positive 2, negative 3. Positive 2 plus negative 3 is negative 1. Positive 2 times negative 3 is negative 6. So 2 and 3 works. I can keep first term the same. Keep last term the same. Rewrite the middle term as plus 2y minus 3y. I rewrite 1y as plus 2y minus 3y using these two numbers with the same variable. Now we get 4 terms. I can factor this by grouping. For the first two terms, 6y squared plus 2y. The greatest common factor is 2. That's the largest number we are allowed to divide for both numbers. Then the common letter is y. If I pull out 2y, what's left here? 6 divided by 2 is 3. Y squared means there are two y's. If I pull out one of them, another one left here. Second term, positive 2 divided by 2 is 1. There's only one y. If I pull a y, there's no y left. I get 2y, 3y plus 1. Second half, greatest common factor for 3 and 1 is 1. That's the largest number I'm allowed to divide for both numbers. If the leading term is negative, I need to pull out negative sign. If the leading term is negative, I need to pull out negative sign. And y, there's no common letter. Y is not common. So negative 1 is a common factor. If I pull out negative 1, take negative 3 divided by negative 1, which is positive 3. Letter y stays the same. Negative 1 divided by negative 1 is positive 1. Now we can see that here. 3y plus 1 is a common factor. 3y plus 1 is a common factor. If I pull out 3y plus 1, what's left is 2y minus 1. And for the final answer, don't forget there's a 2y outside the parentheses. Bring it down. For the final answer, don't forget there's a 2y outside the parentheses. Bring it down. That's the final answer. 2y times 3y plus 1 times 2y minus 1. That's the final answer. Next example. 18x cubed minus 21x squared minus 9x. Observe first. If there's a common factor, we must pull it out first. Observe first. Before we apply AC method, if there's a common factor, we must pull it out first. Here, the common factor for 18, 21, and 9 is 3. 3 divides all three numbers, and that's the largest possible number that divides all three numbers. And common letter is x. Common letter is x, so we pull out 3x. 18 divided by 3 is 6. X to the power 3 means we have 3x multiplied together. If I pull out one of them, we have 2x left inside the parentheses. Next term. 21 divided by 3 is 7. X squared means there are 2x multiplied together. If I pull out one of them, the other one stays there. Last term. 9 divided by 3 is 3. There is only one x. If I pull out x, there's nothing left. There's no x left. Now we have 3 terms here. We can try to apply AC method. Now we have 3 terms in the parentheses. We can try to when there are 3 terms inside parentheses, we can try to apply AC method. That's a trinomial. We can try to apply AC method. A times C. 6 times negative 3 is negative 18. Next, we try to find two numbers that they multiply to be negative 18, add to be negative 7. We try to find two numbers that they multiply to be negative 18, add to be negative 7. We can try 18 equal to 1 times 18, or 2 times 9, or 3 times 6. That's all possibilities. And we can see that 9 minus 2 is 7. 9 minus 2 is 7. But we want negative 7 here. So we can make positive 2 and negative 9. Positive 2 times negative 9 is negative 18. Positive 2 plus negative 9 is negative 7. Positive 2 times negative 9 is negative 18. Positive 2 plus negative 9 is negative 7. So we leave the first term the same. Leave the last term the same. Replace the middle term with these two numbers. Plus 2x minus 9x. Replace the middle term using these two numbers, but keep the variable the same. Replace the middle term with these two numbers, but keep the variables the same. Variable is x, keep it the same. Now we have four terms. When there are four terms, we can try to factor this by grouping. When there are four terms, we can try to factor by grouping. Factor the first two terms. For the first two terms, 6x squared plus 2x. Common factor is 2. That's the largest number that divides both numbers. And common variable is x. Choose the lowest power. Choose the lowest power. Lowest power is power 1. Usually if the power is 1, we don't write 1. So the common factor is 2x. 6 divided by 2 is 3. X squared divided by x. X squared means there are 2x. If I pull out one of them, another one left there. X squared means there are 2x. If I pull out one of them, the other one left inside the parentheses. Next term, 2 divided by 2 is 1. And there's only one x. If I pull it out, no more x left. Now for the second half. For 9 and 3, the greatest common factor is 3. That's the largest possible number that divides both numbers. Then, since the leading term is negative, we must keep negative sign. We need to pull out negative sign. If the leading term is negative, we must pull out negative sign. And then there's no common letters. We can see that there's no common letters. First term contains x, but second term doesn't. There's no common letters. So negative 3 is the greatest common factor. Now what's left here? Negative 9 divided by negative 3 is positive 3. Negative 9 divided by negative 3 is positive 3. X stays there. Second term, negative 3 divided by negative 3 is positive 1. Now you can see that here. 3x plus 1 looks exactly the same. 3x plus 1 looks exactly the same, so they are the common factors. If I pull out 3x plus 1, what's left is 2x minus 3. Put in parentheses. If I pull out 3x plus 1, what's left is 2x minus 3. Put in parentheses. Then don't forget, there's a 3 in front of the parentheses. There's a 3x in front of the parentheses. Don't forget. There's a 3x in front of the parentheses. Bring it down. Don't forget 3x. There's a 3x in front of the parentheses. Bring it down. And that's the final answer. Next. 2x squared minus sy minus 10y squared. 2x squared minus sy minus 10y squared. So observe, if there's common factor, we must pull it out first. Here for 2, negative 1, 10, there's no common factor. In the middle term, there's no numbers here. There's no common factor here. If there's no common factor, we can apply AC method directly. If there's no common factor, we can apply AC method directly. Multiply first coefficient with the last coefficient. 2 times negative 10 is negative 20. 2 times negative 10 is negative 20. We try to find two numbers that multiply to be negative 20, add to be the middle term. Here, middle coefficient is -1. If there's no number in the front, we assume the number in the front is 1. So the middle coefficient is -1. The middle coefficient is -1. Here we try to find two numbers that they multiply to be -20 and they add to be -1. We try to find two numbers that they multiply to be -20, add to be -1. For 20, that's easy. We can try 4 and 5. We want to make -1 here, so I can make +4 -5. +4 plus -5 is -1. And +4 times -5 is -20. +4 times -5 is -20. So I keep first term the same. Keep last term the same. Replace the middle term using these two numbers. But keep the variables the same. I have +4xy minus 5xy. Replace the middle term with using these two numbers. But keep the variables the same. Then we have 4 terms. I can factor by grouping. Now when I have 4 terms, I can factor it by grouping. For the first 2 terms, take out common factor. For 2 and 4, common factor is 2. That's the largest number that divides both 2 and 4. Common letter is x. Common letter is x. And choose the lowest power. For x, choose the lowest power. We have power 2, power 1. Lowest power must be power 2. Pull out 2x. What's left? 2 divided by 2 is 1. S squared means there are 2x multiplied together. If I pull out one of them, the other one left inside the parentheses. Second term. 4 divided by 2 is 2. There's only one x. I pull out x. If I pull out x, there's no x left. But since I only pull out x, y stays there. So I get -1. I get 1x plus 2y in the parentheses. But remember, when the exponent, when the coefficient is 1, when the coefficient of a term is 1, we can always drop 1. When the coefficient is 1, we always drop 1. 1x is the same as x. For the second half, common factor between 5 and 10 is 5. Common factor between 5 and 10 is 5. That's the largest number that divides both 5 and 10. When the leading term is negative, we need to pull out negative sign. When the leading term is negative, we need to pull out negative sign. Next, the common letter here, common variable is y. Y is the common letter. And we choose the lowest power. We choose the lowest power. Lowest power is 1. When the power is 1, usually we don't write 1. So the common factor is -5y. If I pull out -5y, what's left here? -5 divided by -5 is +1. Since I only pull out y, so this x stays there. Second term, -10 divided by -5 is +2. -10 divided by -5 is +2. Y squared means there are 2 y's. If I pull out one of them, the other one stays inside. Then, when the coefficient is 1, for 1x, when the coefficient is 1, we don't write 1 in general. When the coefficient is 1, we don't write 1. 1x is the same as x. Then we can see that x plus 2y is the common factor. X plus 2y is the common factor. So put it outside. If I pull out x plus 2y, what's left is 2x minus 5y. Put in parentheses, 2x minus 5y. If I pull out x plus 2y, put it in the front, what's left is 2x minus 5y. And that's the final answer. Next problem. 5x squared minus 13sy minus 6y squared. So when there are 3 terms and there's no common factors, we need to apply AC method. If there's a common factor, we must pull out first. But when there's no common factor, we apply AC method directly. A times C. 5 times -6 is -30. 5 times -6 is -30. Now we try to find two numbers that multiply to be -30 add to be negative 13. We try to find two numbers, then they multiply to be negative 30, add to be negative 13. What can we try? If we try 10 and 3, 10 plus 3 is 13. And we try negative 10, negative 3. Negative 10 plus negative 3 is negative 13. But negative 10 times negative 3 is not negative 30. Negative 10 times negative 3 is not negative 30. So 10 and 3 doesn't work. Let's write down all possibilities for 30. Let's write down all possibilities for 30. 30 we can try 1 times 30, 2 times 15, 3 times 10, 4, 5 times 6. So that's all possibility for 13. And we know 10 and 3 doesn't work. 15 minus 2 is 13. 15 minus 2 is 13. So let's try 15 and 2, see if it works. There's a lot of trial and error. There's a lot of trial and error. Let's try 15 and 2 first. Let's try 15 and 2. In order to make negative 13, I can try positive 2, negative 15. Positive 2 plus negative 15 is negative 13. Positive 2 times negative 15 is negative 30. Positive 2 times negative 15 is negative 30. So positive 2 and negative 15 works. If this pair works, we remove the middle term. Keep the first term the same. Keep the first term and the last term the same. Remove the middle term. Replace the middle term using these two numbers. Plus 2sy minus 15sy. Replace the middle term using these two numbers, positive 2 and negative 15, and the variables stays the same. Now we have 4 terms. When there are 4 terms, we can factor this by grouping. When there are 4 terms, we can try to factor by grouping. For the first 2 terms, take a common factor. For 5 and 2, common factor is 1. For 5 and 2, the common factor is 1. Common letter is x. Common letter is x. If I pull out 1x, when the coefficient is 1, usually we don't write 1. When I pull out 1x, if the coefficient is 1, usually we don't write 1. 1x is the same as x. If I pull out x, 5x squared means there are 2x multiplied together. If I pull out one of an x, the other x stays there. Second term, number 2 stays there. There's only one x. If I pull out x, there's no more x left. But since I only pull out x, letter y stays the same. That's the first half. For the second half, we find a common factor for 15 and 6. We find the greatest common factor for 15 and 6. For 15 and 6, the greatest common factor is 3. That's the largest number that divides both 15 and 6. And for factoring, when the first term is negative, we pull out negative sign. And the common letter here is y. Common letter is y. Pick the lowest power. We have power 1, power 2. The lowest power is power 1. If I pull out negative 3y, for the first term, negative 15 divided by negative 3 is positive 5. Since I only pull out y, letter x stays the same. For the second term, negative 6 divided by negative 3 is positive 2. Since I pull out one of the y, we have y squared here. Y squared means 2 y's multiplied together. Since I pull out one of the y's, we have another y left inside the parentheses. Now we can see that 5x plus 2y and 5x plus y looks exactly the same. 5x plus 2y and 5x plus 2y looks exactly the same. So I can pull out 5x plus 2y. If I pull out 5x plus 2y, what's left is x minus 3y. That's the final answer. Next. 12x squared plus 28sy plus ay squared. First of all, let's observe, is there any common factors? If there is common factor, we must pull out a common factor first. Let's observe first, is there any common factors? If we observe here, for 12, 28 and a, number 4 is a common factor. 4 is the number that divides all three numbers. And also 4 is the largest possible number that divides all three numbers. And there are no common letters. First one only have x, last one only have y. There's no common factor. There are no common letters. So the only common factor is 4. If I pull out 4, first term, 12 divided by 4 is 3. S squared stays the same. Second term, 28 divided by 4 is 7. S and y stays the same. Third term, 8 divided by 4 is 2. Y squared stays the same. Now I can use AC method. A times C. 3 times 2 is 6. We try to find two numbers that they multiply to be 6, add to be 7. We try to find two numbers that they multiply to be 6 and they add to be 7. We can try 1 and 6. Positive 1, positive 6. Positive 1 plus positive 6 is positive 7. Positive 1 times positive 6 is positive 6. So 1 and 6 works. So here I keep the first term the same, keep the last term the same. I rewrite the middle term using these two numbers. 1sy plus 6sy. Rewrite the middle term using these two numbers. Keep the variables the same. Now we have 4 terms. When there are 4 terms, we can try to factor by grouping. When there are 4 terms, we can try to factor by grouping. For the first 2 terms, take out common factor. For the first 2 terms, take out common factor. For 3 and 1, common factor is 1. For 3 and 1, common factor is 1. Common letter is x. Lowest power for x, lowest power is power 1. If the power is 1, we don't know power 1. So 1x is the common factor. If I pull out 1x, 3 divided by 1 is 3. X squared means there are 2x multiplied together. If I pull out one of them, the other one left inside. Second term, 1 divided by 1 is 1. There's only 1x. If I pull out x, there's no more x left. Since I only pull out x, y stays there. Now be very, very careful. For every term, any term, if the coefficient is 1, we don't write 1. For any term, if the coefficient is 1, we don't write 1. So 1x is the same as x. 1y is the same as y. If the coefficient is 1, we don't write 1. Second half, take out common factor. For 6 and 2, the greatest common factor is 2. 2 is the largest possible number that divides both numbers. Common letter is y, and for letter y, the lowest power is power 1. Pull out 2y. 6 divided by 2 is 3. Since I only pull out y, x stays the same. Second term, 2 divided by 2 is 1. Y squared means there are 2 y's multiplied together. If I pull out one of them, the other y left there. So that's what we have when I pull out 2y. Now, if the coefficient is 1, for any polynomial, if the coefficient is 1, we don't write 1. So 1y is the same as y. 1y is the same as y. Now we can see that we have 3x plus y. That's the common factor. We have 3x plus y. 3x plus y. That's the common factor. If I pull out 3x plus y, what's left is x plus 2y. What's left is x plus 2y. Now, don't forget, there's a number 4 in the front. Bring 4 down, then that will be the final answer. There's number 4 in front of the parentheses. Bring it down. That's the final answer. Next. 36c squared minus 12cd minus 15d squared. First observe, is there any common factor? If there is common factor, we must pull it out first. Observe 36, 12, and 15. 36, 12, and 15. It looks like 3 divides all three numbers. It looks like 3 divides all three numbers. So 3 is the common factor. And 3 is the largest possible number that divides all three numbers. That's the greatest common factor. Is there any common letters? C is not common because there's no C here. And letter D is not common because there's no D in the first term. So there are no common letters. 3 is the only common factor. Now pull out 3. If I pull out 3, 36 divided by 3 is 12. C squared stays the same. 12 divided by 3 is 4. CD stays the same. $15 divided by 3 is 5. D squared stays the same. Then when there are three terms, we can apply AC method. When there are three terms, we can apply AC method. A times C. 12 times negative 5 is negative 60. 12 times negative 5 is negative 60. Now we try to find two numbers. We try to find two numbers that they multiply to be negative 60 and they add to be negative 4. 60 is not easy. Let's write down all possibilities first. 60, I can try 1 times 60, or I can try 2 times 30, or 3 times 20, or 4 times 15, 5 times 12, or 6 times 10. 7 doesn't work, 8 doesn't work, 9 doesn't work, so that's it. Now let's compare each pair. Which pair of number can give you 4? It looks like the only possibility here is 10 minus 6 is 4. So let's try 10 and 6. It looks like 10 minus 6 is 4. But we want to get negative 4 here. We can try negative 10, positive 6. Negative 10 plus positive 6 is negative 4. Negative 10 plus negative 10 times positive 6 is negative 60. So 10 and 6 works. Let's remove the middle term. Using these two numbers to rewrite the middle term. And write it as negative 10 CD plus 6 CD. Use these two numbers, rewrite the middle term. Keep the variables the same. Keep the letters the same. Now we have 4 terms. When there are 4 terms, we can factor by grouping. When there are 4 terms, we can factor by grouping. So, group first 2 terms together, take out common factor. For 12 and 10, common factor is 2. Is there any common letter? Common letter is C. Pick the lowest power. For letter C, the lowest power is power 1. So take out 2C. If I take out 2C, 12 divided by 2 is 6. C squared means there are 2 C's multiplied together. If I pull out one of them, the other C left inside the parentheses. Second term, 10 divided by 2 is 5. There's only one C. If I pull out C, there's no C left. Since I only pull out C, D stays the same. So I get 2C times 6C minus 5D. That's the first half. Second half, the greatest common factor for 6 and 5. For 6 and 5, the greatest common factor is 1. That's the largest possible number that divides both numbers. Then the common letter for 6CD and D squared, the common letter is D. Pick the lowest power. Lowest power is power 1. If the power is 1, we don't write 1. Now, for any term, if the coefficient is 1, we don't write 1. 1D is the same as D. 1D is the same as D. If I pull out D, for the first term, 6C stays the same. And there's only one D. If I pull it out, there's no D left. For second term, negative 5 stays the same. D squared means there are 2 D's multiplied together. If I pull out one of them, the other one left later. Now we can see that 6c minus 5d and 6c minus 5d, they are common factors. 6c minus 5d and 6c minus 5d, they are common factors. If I pull it out, if I pull out 6c minus 5d, what's left is 2c plus d. What's left is 2c plus d. I can put it in parentheses, 2c plus d. Then, don't forget, there's a number 3 in the front. Don't forget, there's number 3 in front of the parentheses. Bring it down. That's your final answer. That's the final answer. 3 times these 2 parentheses. That's the final answer. Next. Two x squared plus 2x plus 3. First of all, observe, is there any common factor? For 2 to 3, there's no common factor. And there's no common letters. Last term doesn't have any letter, there's no common letter. So since there's no common factor, we can apply AC method directly. AC method. First times last. 2 times 3 is 6. We try to find two numbers that multiply to be 6 and add to be 2. Try to find two numbers that multiply to be 6 and add to be 2. Is it possible? Let's write down all possibilities for number 6. Number 6 can be written as 1 times 6 or 2 times 3. That's the only possibility. 1 times 6 is either 1 times 6 or 2 times 3. That's the only possibility. And we know that 6 plus 1 or minus 1 doesn't give you 2. 3 plus 2 is 5. 3 minus 2 is 1. We don't get 2 here. So that's the only possibility, and none of them works. That means this polynomial is not factorable. That means this polynomial is not factorable. If it's not factorable, we say this is a prime polynomial. If it's not factorable, we say this polynomial is called a prime polynomial. Or simply call it it's a prime. This polynomial is a prime polynomial. Since it's not factorable, it's called prime polynomial. Or you can simply say this is a prime. Next. Three x to the power 4 plus 4x squared minus 4. 3x to the power 4 plus 4x squared minus 4. So first of all, observe, is there any common factors? For the numbers 3, 4, 4, there's no common factor. And there's no common letters. In the last term, there's no x, so there's no common letters. If there's no common factor, we can apply AC method. AC method, first times last. 3 times negative 4 is negative 12. Now, can we find two numbers that they multiply to be negative 6? Sorry, they multiply to be negative 12, and they add to be positive 4. Can we find two numbers that they multiply to be negative 12, and they add to be positive 4? For 12, we can try 1 times 12, 2 times 6, or 3 times 4. There's only 3 possibilities. 12 minus 1 is not 4. 12 plus 1 is not 4. But 6 minus 2 is 4. We can try 6 and 2. We can try the pair 6 and 2. Since I try to make positive 4, I can make negative 2 and positive 6. Negative 2 plus positive 6 is positive 4. And when I multiply, negative 2 times positive 6 is negative 12. So negative 2 and positive 6 works. So keep the first term the same. Keep the first term the same. Keep the last term the same. Rewrite the middle term using these two numbers. Rewrite the middle term using these two numbers. I can write it as negative 2x squared plus 6x squared. Use these two numbers, rewrite the middle term. And the variables, the letters stays the same. X squared stays the same. Now we have 4 terms. I can factor by grouping. When we have 4 terms, we can factor it by grouping. For the first 2 terms, take out common factor. For 3 and 2, the common factor is 1. For 3 and 2, the common factor is 1. That's the largest number that divides both numbers. Common letter is x squared. Common letter is x, and the lowest power is x squared. If I pull out 1x squared, 3 divided by 1 is 3. X to the power 4 means there are 4x multiplied together. If I take out 2 of them, another 2 left inside. Second term, 2 divided by 1 is 2. 2 divided by 1 is 2. X squared means there's only 2x multiplied together. If I pull out 2 of them, there's no more x left inside. Second half, for 6 and 4, common factor is 2. For number 6 and number 4, common factor is 4. If I pull out 2, common factor is 2. If I pull out 2, 6 divided by 2 is 3. X squared stays the same. 4 divided by 2 is 2. Now we can see that here. 3x squared minus 2 stays the same. 3x squared minus 2. 3x squared minus 2 stays the same. And if I pull out 3x squared minus 2, what's left is 1x squared plus 2. And for your final answer, if the coefficient is 1, we drop 1, don't write 1. For the final answer, if the coefficient is 1, we don't write 1, drop 1. 1x squared is the same as x squared. That's the final answer. Next. 10x to the power 4 minus 9x squared y plus 2y squared. 10x to the power 4 minus 9x squared y plus 2y squared. First of all, try to take out common factor. Is there any common factor? For 10, 9, and 2, there's no common factor. Is there any common letters? First term contains only x, there's no y, so y is not common. Last term contains only y, there's no x, that means x is not common. So there are no common factors here. If there are no common factor, we can apply AC method directly. If there are no common factor, we can apply AC method directly. A times C, 10 times 20 is first times last, 10 times 2. First times last, 10 times 2 is 20. Can we find two numbers that they multiply to be 20, add to be negative 9? Can we find two numbers that they multiply to be 20, add to be negative 9? For 20, we can try 4 times 5. We know negative 4 times negative 4 plus negative 4 is negative 9. And negative 4 times negative 4 is 20. So negative 4 and negative 5 works. Negative 4 plus negative 4 is negative 9. Negative 4 times negative 5 is positive 20. So use AC method. I keep the first term the same. Keep the last term the same. Rewrite the middle term using these two numbers. And keep the variables the same. Rewrite the middle term using these two numbers. And keep the variable the same. (4x squared y minus 5x squared y). Rewrite the middle term using these two numbers. Keep the variables the same. Keep x squared y the same. Now we have 4 terms. We can factor by grouping. Now we have 4 terms. We can factor this by grouping. For the first half, 10x to the power 4 minus 4x squared y. Take out common factors. For 10 and 4, common factor is 2. That's the largest number that divides both 10 and 4. Common letter is x. Lowest power for x is power 2. and y is not common. So greatest common factor for the first half is 2x squared. If I pull out 2x squared, what's left is 10 divided by 2 is 5. X to the power of 4 means there are 4x multiplied together. If I pull out 2 of them, there's another 2 left inside. Second half, 4 divided by 2 is 2. X squared means there are only 2x multiplied together. If I pull out x squared, there's no x left. Since we only pull out x squared, so letter y stays the same. That's in the first half. For the second half, we take our common factors also. For 5 and 2, the common factor is 1. That's the largest number that divides both 5 and 2. And the common letter is y. The common letter is y. Lowest power for letter y, lowest power is power 1. If the power is 1, we don't write 1. Now, when the leading term is negative, we need to put our negative sign. So common factor is negative 1y. Negative 5 divided by negative 1 is positive 5. X squared stays there. Since I only pull out y, x squared stays there. There's only 1y. If I pull out y, there's no y left. For the second half, positive 2 divided by negative 1. Positive 2 divided by negative 1 is negative 2. Y squared means there are 2 y's multiplied together. If I pull out one of the y's, there's another y left. Now, for any term, if the coefficient is 1, for any term, if the coefficient is 1, we don't write 1. So 1y is the same as y. 1y is the same as y. Then we can see that here. Common factor is 5x squared minus 2y. The common factor is 5x squared minus 2y. Pull out 5x squared minus 2y. What's left is 2x squared minus y. What's left is 2x squared minus y. And that's the final answer. Next. 3x squared plus 2x plus 4. 3x squared plus 2x plus 4. First of all, we try to take our common factor first. Is there any common factor for 3, 2, and 4? For 3, 2, and 4, there's no common factor. Is there any common letters? In the last term, there's no x, so x is no common letter, so there are no common letters. Then, since there's no common factor, we can apply an AC method. For AC method, we multiply first to the last. 3 times 4 is 12. Can we find two numbers that multiply to be 12, add to be 2? Let's write down all possibilities here for number 12. 12 can be written as 1 times 12, or 2 times 6, or 3 times 4. That's all possibility for number 12. Is it possible that I can make 2? 12 plus 1 is not 2. 12 minus 1 is not 2. 6 plus 2 is not 2. 6 minus 2 is not 2. 4 minus 3 is not 2. 4 plus 3 is also not 2. So it's impossible to have a 2 here. It's impossible to have a 2 here. That's why. In this case, we say this polynomial is not factorable. There's no way we can get 2 in the middle. So this polynomial is not factorable. Or we can say this is a prime polynomial. Prime polynomial is the same as saying this polynomial is a prime. So it's not factorable. That's the final answer. Next, I'll show you factoring by formulas. Factoring by formulas. What formula do we know so far? Last week we learned 3 formulas. That says a plus b times a minus b equal to a squared minus b squared. A plus b squared equal to a squared plus 2ab plus b squared. a minus b squared equal to a squared minus 2ab plus b squared. That's what we learned last week. And we know operation from left to right is called multiplication. Operation going backward is called factorization. Today we are learning factoring. So going backward, we try to make right side equal to left side. So this formula can be rewritten as a squared minus b squared equal to a plus b times a minus b. A squared plus 2ab plus b squared equal to a plus b squared. A squared minus 2ab plus b squared equal to a minus b squared. So that's the modified formula. Make right side equal to left side, going backward. That's called factorization. Factoring by formulas. We try to use this formula to do these three formulas to do factoring. And remember the name. First one is called difference of perfect squares. Remember the name. Difference of perfect squares. The second one and the third one, they are called perfect square trinomials. So keep this formula in mind. We'll use this formula to do factoring. First example, x squared minus y squared. If we try to match this equation with one of the formula, it matches the first one. X squared minus y squared, it matches the first one. So our x represents A, y represents B, it matches the first one. X represents A, y represents B. So if I use the formula, I have x plus y, x minus y. X represents A, y represents B. We have x plus y, x minus y. That's how we factoring using formulas. That's how we factor using formulas. Number 2. X squared plus y squared. X squared plus y squared. First of all, they have no common factors. And x squared plus y squared, it doesn't match any of these formulas. X squared plus y squared, it doesn't match any of these formulas. And there are no common factors. So this is not factorable. It doesn't match any of these formulas. And there's no common factor, there's nothing I can take it out. So this is not factorable. It doesn't match any of these formulas. And there's no common factors, nothing can be taken out. So this is not factorable. We leave it the way it is. Next. X squared minus 1. X squared minus 1. It looks like the first formula. X represents A. How about 1? Number 1 can be rewritten as 1 squared. Number 1 can always be rewritten as 1 squared. Now it matches the first formula. X squared minus 1 squared. X represents A. Number 1 represents B. So if I plug in, I have x plus 1, x minus 1. That's the final answer. Next, x squared minus y to the power of 3. X squared minus y of power 3. Does it match any of this formula? X squared match A squared, but y to the power 3 doesn't match B squared. Y to the power 3 doesn't match B squared. So we can use the formulas. Is there any common factor I can take out? It doesn't match the formula, and there's no common factor I can take out. This is not factorable. This is not factorable. If there's no common factor and it doesn't match any of these formulas, it's not factorable. Next, x squared minus 81. S squared minus 81. Does it match any formula here? S squared minus 81. It looks like it matched the first formula. S squared match A squared. 81 can be rewrite as 9 squared. 81 can be rewrite as 9 squared. And 9 squared match B squared. So x represent A, 9 represent B. If I plug in, I have x plus 9 times x minus 9. That's the final answer. Next, 4x squared minus 9y squared. 4x squared minus 9y squared. Does it match any of these formulas? There are two terms. It looks like it matched the first formula. Does it completely match? Does it completely match? Number 4 can be rewrite as 2 squared. So 4x squared can be rewrite as 2x squared. Number 9 can be rewrite as 3 squared. So 9y squared can be rewrite as 3y squared in parentheses. So it looks like 2x squared match A. 3y. 2x squared match A squared. 3y squared match B squared. So 2x represent A. 3y represent B. If I plug in, I have 2x plus 3y times 2x minus 3y. 2x plus 3y, 2x minus 3y. In general, let me give you some hint. In order to use this formula has a name called difference of perfect squares. Difference means subtraction. Perfect square, A squared is perfect square, B squared is perfect square. That's called difference of perfect squares. If we observe this term, 4 is a perfect square. S squared is a perfect square. 9 is a perfect square. Y squared is also a perfect square. If everything is a perfect square, and we're doing subtraction, it definitely matches the difference of perfect square. If everything is a perfect square and we have subtraction in the middle, it will match the difference of perfect squares. So keep this idea in mind. If every term is a perfect square, 4 is 2 squared, 9 is 3 squared, S squared is a perfect square, Y squared is also a perfect square. If every term is a perfect square and we have subtraction in the middle, that matches the formula of difference of perfect squares. Keep this idea in mind. Next, 81 x to the power 4 minus 16 y to the power 4. 81 x to the power 4 minus 16 y to the power 4. Observe here, 81 is a perfect square. 9 times 9 is 81. 9 squared is 81. X to the power 4 is a perfect square because x squared is x to the power 4. 16 is a perfect square. 4 times 4 is 16. Y to the power 4 is a perfect square because y to the power 2, y squared raised to the power 2 is y to the power 4. So if they are all perfect squares and we have subtraction in the middle, we can apply difference of perfect squares. So first term can be rewrite as ax squared, 9x squared. 81 is 9 squared. X to the power 4 is x squared. Second term, 16 is 4 squared. Y to the power 4 is y squared. Here everything is a perfect square. We have subtraction in the middle. Then you can try to match the formula. 9a squared represents A. 9x squared represents A. 4y squared represents B. If I use the formula, I have 9x squared plus 4y squared, 9x squared minus 4y squared. If I use the formula, that's what I get. A plus B times A minus B. Now, be very, very careful here. We are not done. Be very, very careful here. We are not done. For the first half, when there's addition, it doesn't match any of these formulas. First part, we are done. But for the second part, observe carefully. 9 is a perfect square again. 9 is 3 times 3. 4 is a perfect square. 4 is 2 times 2. S squared is a perfect square. Y squared is a perfect square. Everything here is perfect square. We have subtraction in the middle. That's another difference of perfect square. 3x squared minus 2y squared. 3 times 3 is 9. 9 is 3 squared. 2 times 2 is 4. 4 is 2 squared. So again, use the formulas. Difference of perfect squares. Use the formulas. Difference of perfect squares. 3x, if I use the formula again, 3x represents A. 2y represents B. If I use the formula again, 3x represents A. 2y represents B. Use the formula again, we have A plus B times A minus B. Now we are done. And it cannot be factored any further. And don't forget the first part. Carry in the first part. Don't forget the first part. I have to carry over. That's the final answer. That's the final answer. Next. 36x squared minus 25y to the power of 4. 36x squared minus 25y to the power of 4. It looks like it matches the first formulas. It looks like it matches the first formula. 36 is a perfect square. 36 can be rewrite as 6 squared. X squared is a perfect square. 36 is 6 squared. 25 is 5 squared. Y to the power of 4 is y squared squared. Y to the power of 4 is y squared squared. So let's match the first formula. 6x represents A. 5y squared represents B. 6x represents A. 5y squared represents B. If I use the formula, if I use the first formula, A plus B times A minus B, I have 6x plus 5y squared times 6x minus 5y squared. Then can we factor further? When we see addition, it doesn't match any of this formula. It's not factorable. But when we see subtraction here, is it factorable? When we see subtraction in the middle, is it factorable? Remember, first both terms must be perfect square. 6 is not perfect square. X is not perfect square. 5 is not perfect square. If they are not all perfect squares, it's not factorable. If any part of this expression is not perfect square, it's not factorable. So that's your final answer. We can't go any further. That's the final answer. Next. X to the power 5 minus 4x to the power 3. If we try to match the formula, we can see that x to the power 5 is not a perfect square. X to the power 3 is not perfect square. It doesn't match any perfect square here. But let's observe. Do they have any common factor? Do they have any common factor? They have a common letter x. They have a common letter x. If I pull out a common factor, what do we have? They have a common letter x. Lower power is 3. If I pull out x to the power 3, what do we get? First term is x to the power 5. X to the power 5 means there are 5x multiplied together. If I pull out 3 of them, I have 2 more left in the parentheses. Second term, 4x to the power 3 Number 4 stays the way it is. X to the power 3 means there are 3x multiplied together. If I pull out 3 of them, there are no x left. Now observe again. S squared is a perfect square now. 4 is also perfect square. That's difference of perfect squares. Now imagine the first formula. That's difference of perfect squares. That's x squared. Number 2 is 2 squared. Number 4 is 2 squared. Let's match the first formula. So we have x represent a, 2 represent b. We have a plus b times a minus b, which is x plus 2 times x minus 2. First term, x to the power 3 stays the way it is. That's the final answer. Next, x to the power 3y minus 9x to the power 5. 9xy to the power of 5. X to the power 3 times y minus 9x to the power 5. If we try to match the formula, it doesn't match any of these formulas. But if we try to take our common factor first, we have x as a common factor. Lower power is 1. We have y as a common factor. Lower power is also 1. Let's take out a common factor. X to the power 3 means there are 3x multiplied together. If I pull out one of them, we have 2 more left in the parentheses. There's only one y. If I take out y, there are no y left. In the second term, number 9 stays the way it is. If I pull out x, there are no more x, no x left. We have y to the power of 5. That means there are 5 y's multiplied together. If I pull out one of them, there are 4 more left in the parentheses. Now observe again, are they perfect squares? Are they perfect squares? S squared is a perfect square. That's x squared. Number 9 is also perfect square. 3 times 3 is 9. Y to the power 4 is also perfect square. Y squared is y to the power 4. So they are both perfect squares. If we try to imagine the first formula. Imagine the first formula. X represents a. 3y squared represents b. So if I use the formula, I have a plus b times a minus b, which is x plus 3y squared and x minus 3y squared. And don't forget sy in the front, bring it down. We have xy times x plus 3y squared times x minus 3y squared. Next. For x to the power 4 y squared minus 25. 4x to the power 4 y squared minus 25. If we try to match the formula, imagine the first formula. Number 4 is a perfect square. X to the power 4 is a perfect square. Y squared is perfect square. 25 is also perfect square. That's difference of perfect squares. 4x squared, 4x to the power 4 y squared can be written as 2x squared y squared. Number 4 is 2 squared. X to the power 4 is x squared squared. Y squared is y squared. 25 is 5 squared. If you try to match the first formula, 2x squared y represents a. Number 5 represents b. Then plug in, we have 2x squared y plus 5 times 2x squared y minus 5. That's the final answer. Next. 36x squared minus 9y squared. 36x squared minus 9y squared. 36 is 6 squared. X is x squared. They are perfect squares. Number 9 is 3 squared. Y is y squared. They are both perfect squares, and they match the first formula. So 6x represents A, 3y represents B. We have 6x plus 3y times 6x minus 3y. Now, be very, very careful. Are we done with the problem? We use the formula, then are we done with the problem? Observe the first part. 6x and 3y. Do you see any common factor here? Do you see any common factor? For 6 and 3, we can tell that 3 is a common factor. 3 divides both 6 and 3, so 3 is a common factor. If I pull out 3, 6 divided by 3 is 2. X stays the same. 3 divided by 3 is 1. Y stays the same. For the second part, 3 is also a common factor. If I pull out 3, 6 divided by 3 is 2. X stays the same. 3 divided by 3 is 1. Y stays the same. Then for the final answer, number 3, both number 3 is outside the parentheses. So I multiply 3 to 3, I get 9. First part is 2x plus 1y. 1y is the same as y. Second part, 2x minus 1y. 1y is the same as y. So I get 2x minus y. That's the final answer. We need to factor completely. That's the final answer. Sometimes factoring may take multiple steps. Next. X to the power 5 minus x. X to the power 5 minus x. So they are not perfect squares. Both terms, they are not perfect squares. So this formula doesn't match any of the above formulas. But I can try to take out common factors. X is a common factor. If I try to take out s as common factor, what do I get? If I pull out x to the power 5 means there are 5x multiplied together. If I pull out one of them, we have 4 more in the parentheses. Second part, there's only 1x. If I pull out x, there's nothing left. If there's nothing left, we cannot leave it blank. We write number 1 as a placeholder. If I pull out x, there's nothing left. If there's nothing left, we cannot leave this place blank. We write 1 as a placeholder. Next, can we factor further? X to the power 4 is a perfect square that can be rewritten as x squared. Number 1 can be rewritten as 1 squared. Now imagine the first formula. Imagine the difference of perfect square. Imagine the first formula. We have, if we use the formula a plus b times a minus b, we have x squared plus 1 times s squared minus 1. S squared plus 1. This is not factorable. I leave it the way it is. This is not factorable. I leave it the way it is. But x squared is a perfect square. S squared is a perfect square. Number 1 is a perfect square. So the last part again matches this formula again. The last part matches this formula again. If I use the formula, I have a plus b times a minus b. So the last part can be rewritten as a plus 1 times a minus 1. We need to keep the first parentheses the same. X squared plus 1. Also, we need to keep this x the same. This x stays outside the parentheses, it stays the same. That's the final answer. We need to factor completely. Next. 16x to the power 4 minus 1. 16x to the power 4 minus 1. So we first of all try to match the formula. 16 is a perfect square. 4 times 4 is 16. X to the power 4 is also a perfect square. X squared is x to the power 4. So 16x to the power 4 can be rewritten as 4x squared. Number 1 is a perfect square. Number 1 can be rewritten as 1 times 1. So if I if I match this with the first formula, I have a plus b times a minus b. So if I use the formula, I have 4x squared plus 1 times 4x squared minus 1. A plus b times a minus b, it matches the first formula. Then, can we factor further? 4x squared plus 1, this doesn't match any of the formulas. For 4x squared plus 1, it doesn't match any of this formula. But for 4x squared minus 1, number 4 is a perfect square. X is a perfect square. We have 2x squared. Number 1 is a perfect square. That's 1 square. So again, it matches the first formula. So it's a minus b. A squared minus b squared. So using the formula, we have a plus b times a minus b. This parenthesis stays the same. 4x squared plus 1. That's the final answer. Next one. X squared plus 6x plus 9. When there are 3 terms, we can try to match the perfect square trinomials. Observe, first one is a perfect square, that's x squared. Last term is also perfect square, number 9 is 3 squared. So we know that a equal to x, b equal to 3. Then what's 2ab? A equal to x, b equal to 3. What's 2ab? (2ab) equal to 2 times a times b. 2ab equal to 2 times a times b. A is x, b is 3, which is 6x. So this equation match perfect square trinomial. This equation match perfect square trinomial. So if 6s match the middle term, we can use perfect square trinomial to factor this. Equal to a plus b squared, which is x plus 3 squared. This way, it match perfect square trinomial. We apply the formula, we get a plus b squared. Next, x squared minus ax plus 16. X squared minus ax plus 16. First term is a perfect square. First term is a perfect square. It's x squared. So a is x. Last term is also perfect square. Last term is also perfect square. It's 16 is 4 squared. So b equal to 4. Middle term represent 2ab. Middle term represent 2ab. What's 2ab here? If the middle term match 2ab, we can use perfect square trinomial. Otherwise, we can't use it. Let's try to find out what's 2ab. 2ab is twice a times b, which is 2 times 4 is ax. So 2ab match the middle term. This is minus 2ab. The middle term here is minus 2ab, so it must be this formula. A squared minus 2ab plus b squared. The middle term match negative 2ab. So it should be a minus b squared. Answer should be a minus b squared. That's the answer. For number 15 and 16, if you can match the formula, for number 15 and 16, if you can match the formula, last class I showed you a way to factor trinomial with no leading coefficient. Last class, I showed you a way to find answer. Last class, I showed you how to factor trinomial with no leading coefficient. So, first of all, draw two parentheses. Split x squared evenly. Split x squared evenly. Find two numbers, then multiply to be 9, add to be 6. Find two numbers, then multiply to be 9, add to be 6. We can try positive 3 and positive 3. Positive 3 plus positive 3 is positive 6. Positive 3 times positive 3 is 9. Put it here. Then when you see x plus 3 times x plus 3, when you see the same thing twice, you can write x plus 3 squared. Without using the formula, we can get the same answer. Without using the formula, we can get the same answer. Same thing for number 16. For trinomials with no leading coefficient, we can try a different way. For trinomials with no leading coefficient, we can try a different way. X squared minus ax plus 16. That's a trinomial and it has no leading coefficient. You can draw two parentheses, put x in the parentheses, then try to find two numbers, then multiply to be 16, add to be negative a. 16 can be factored as 4 times 4. But 4 plus 4 is positive a. We need negative a here. So we can try negative 4 times negative 4. Negative 4 times negative 4 is positive 16. And negative 4 plus negative 4 is negative a. Put it in parentheses. That's the final answer. Now when we see the same thing twice, when we see the same expression twice, if they look exactly the same, we write x minus 4 squared. We get exactly the same answer. When there's no leading coefficient, we can factor perfects, we can factor the trinomials. Answer is the same. That's an old technique we learned last class. We get the same answer without using the formulas. Next, 4p squared minus 4pq plus q squared. Let's observe. Does it match one of this formula? This is a trinomial. It looks like a squared minus 2ab plus b squared. It looks like the third formula. Let's try to match. First term, 4p squared can be rewritten as 2p squared. 4 is 2 squared. P squared is p squared. Last term, q squared is actually q squared. So a represents 2p. B represents Q. How about 2AB? Does 2AB match the middle term? If the 2AB match the middle term, we can use the formula. Otherwise, we can't use it. Does 2AB match the middle term? Let's check. 2 times A times B. 2 times A times B. B represents letter Q. A represents 2P. B represents Q. So 2AB is 2 times 2P times Q. 2 times 2 is 4. P times Q is PQ. So you match the middle term. We use the third formula. We have A is 2P. We have 2P minus Q squared. That's the third formula. Next. 1 over 4 x squared plus 3x plus 9. Let's observe. Does it match one of this formula? Does it match one of this formula? 1 over 4 is a perfect square. That's a half square. X squared is x squared. Number 9 is 3 squared. So first term and last term match. First term and the last term match, a squared and b squared. So a is half of x. B is number 3. Does the middle term match 2ab? Does the middle term match 2ab? If it matches, we can use the formula, otherwise we can't use it. Does the middle term match? 2 times a times b. A is half of x, b is number 3. Let's multiply. 2 times half times 3. 2 times half times 3. Multiply number first. 2 times half times 3. When we multiply whole number to fraction, we first want to write whole number as a fraction. We write number 2 as 2 over 1. Leave a half the way it is. We can rewrite number 3 as 3 over 1. Then when we multiply the top to the top, bottom to the bottom. On the top, 2 times 1 times 3 is 6. On the bottom, 1 times 2 times 1 is 2. 6 divided by 2 is number 3. So when we multiply the number 2 times half times 3, I get 3. Letter x stays the way it is. So 2ab match 3x, it matches the middle term. We are allowed to use the formula. That's a plus b squared. A is half of x. B is 3. Final answer, a plus b squared. Number 19. 1 over 36 x squared plus sy plus 9y squared. Observe, are they perfect squares? Is the first term perfect squares? 1 over 36 is 1 over 6 squared. That's a perfect square. X squared is x squared. That's a perfect square. So first term is a perfect square. That means a is 1 over 6x. That's a. Last term. Is last term perfect square? Number 9 is a perfect square. Y squared is also perfect square. So last term can be rewritten as 3y squared. So b is 3y. A is 1 over 6x. B is 3y. What's 2ab? If 2ab match the middle term, we can use the formula. Otherwise, we can't use it. This one looks like the second formula. If 2ab match the middle term, we can use it. Otherwise, we can't use it. Let's multiply. 2ab. A is 1 over 6x. B is 3y. Let's multiply. 2 times 1 over 6 times 3. What do we get? 2 times 1 over 6 times 3. When we have whole number multiplied by fraction, we first want to rewrite whole number as fractions. I rewrite 2 as 2 over 1. 1 over 6, I leave it the way it is. Number 3, I write it as 3 over 1. Then I multiply the numerator to the numerator and the denominator to the denominator. 2 times 1 times 3 is 6. On the bottom, 1 times 6 times 1 is also 6. 6 divided by 6 is 1. So when I multiply the numbers, 2 times 1 over 6 times 3, I get 1. X times y is sy. And we know that when the coefficient is 1, usually we don't write 1. So 1 sy is the same as sy. It matches the middle term. If we match the middle term, we can use the formula. If we match the middle term, we can use the formula. So that's a plus b squared. A is 1 over 6x. B is 3y squared. That's the final answer. Next, 4x squared minus 15. 4x squared minus 15x plus 9. 4x squared minus 15x plus 9. It looks like the third formula. 4x squared is a perfect square. 4 can be rewritten as 2 squared. 4 can be rewritten as 2 squared. X squared is x squared. So that's a perfect square. It looks like a is 2x. Last term, number 9 is a perfect square. Number 9 is 3 squared. So it looks like b match number 3. How about 2ab? If 2ab match the middle term, we can use this formula. Otherwise, we can't use the formula. What's 2ab? Let's multiply out. 2ab is twice a times b. Twice a times b. Multiply the numbers first. 2 times 2 is 4. 4 times 3 is 12. X stays the same. Multiply the number, I get 12x. 12x doesn't match 15x. 12x doesn't match the middle term. Middle term is 15x. It doesn't match. So we are not allowed to use this formula. If the middle term doesn't match, we can use it. So it doesn't match. It doesn't match the formula ax squared minus 2ab plus b squared. It doesn't match this formula. If it doesn't match, we can use this formula. We need to find a different way to work it out. If it doesn't match, we need to find a different way to work it out. Let's start this problem over. If it doesn't match perfect square trinomial, we can use this formula. We need to find a different way to work it out. When there are 3 terms, another choice is AC method. When there are 3 terms, another choice is AC method. Multiply first and last. A times C. A times C is 36. We try to find 2 numbers that they multiply to be 36. Add to be negative 15. Let's write down all possibilities for 36. 36 can be rewritten as 1 times 36, 2 times 18, 3 times 12, or 4 times 9, or 6 times 6. That's all possibilities. We want 2 numbers, they multiply to be 36, add to be 15. The only possibility is 3 plus 12 is 15. So let's try 3 12. 3 plus 12 is 15, but here we want negative 15. So I can make both of them negative. Negative 3 plus negative 12 is negative 15. When I multiply, negative 3 times negative 12 is positive 36. So imagine we can use negative 3 and negative 12. So for AC method, I keep first term the same. I keep last term the same. I rewrite the middle term using these 2 numbers. Negative 3x minus 12x. I rewrite 15x as negative 3, negative 12. Leave variable the same. Keep the variable the same. I rewrite 15 with negative 3 and negative 12. Keep variable the same. Then we have 4 terms. I can factor this by grouping. For the first 2 terms, common factor between 4 and 3 is 1. 1 is the only number that divides both 4 and 3. Common variable is x. Common variable is x. And lowest power is power 1. If I pull out 1x, 4 divided by 1 is 4. X squared means there are 2x multiplied together. If I pull out one of them, the other one stays there. 3 divided by 1 is 3. There's only 1x. If I pull out x, there's no more x. That's the first term. And when the coefficient is 1, usually we don't write 1. 1x is the same as x. the second half. For 12 and 9, the common factor for 12 and 9, common factor is 3. The greatest common factor is 3. For 12 and 9, the greatest common factor is 3. 3 is an only number that divides both numbers. When the leading term is negative, we need to pull out negative sign. Then if I pull out negative 3, negative 12 divided by negative 3 is positive 4. X stays the same. Positive 9 divided by negative 3 is negative 3. Then we see that 4x minus 3 is a common factor. 4x minus 3 looks exactly the same. If I pull out 4x minus 3, what's left is x minus 3. So if we can use the formula, we need to use AC method. If we can't use the formula, if it doesn't match any formulas, we need to use AC method to factor trinomials. Next, two x plus y squared minus 9. 2x plus y squared minus 9. Which formula does it match? Does it match any formula? Does it match any formula? It looks like it matches the first formula. You see that the first part is a perfect square. Second part, number 9, is 3 squared. So it looks like 2x plus y represent A. Number 3 represent B. And match the formula. If we match the formula, I can use the formula A plus B times A minus B. So 2x plus y plus 3 and 2x plus y minus 3. A plus B times A minus B. That's how we use the formula. Next. X minus 3y squared minus 16. X minus 3y squared minus 16. Does it match any of these formulas? It looks like the first part is a perfect square. Second part, number 16 is also perfect square. 16 is 4 squared. So we have a squared minus b squared. So x minus 3y match A. Number 4 match B. So we have, use the formula A plus B times A minus B. We have x minus 3y plus 4. Times x minus 3y minus 4. It's A plus B. A minus B. In general, factoring polynomial is not easy. Sometimes it requires a lot of trial and error. Next, let me give you the general approach for factoring. Next, let me give you a general approach for factoring. First step, no matter how, if possible, always take out the greatest common factor first. For any problem, if there's a common factor, always take it out first. For any problem about factoring, if possible, always take out the greatest common factor first. That's always the first approach. If possible, take out the greatest common factor first. If there's no common factor, consider the following. When there's no common factor, consider the following. If a polynomial if the polynomial has only two terms, then try to use difference of perfect square. This formula. A square minus b square equal to a plus b times a minus b. If a polynomial has only two terms, we can try to use difference of perfect squares. If the polynomial has three terms, we can try to use AC method. Try to use AC method first. If it's too hard to work it out, you can try to use perfect square trinomials. Try AC method first. If it's too hard to work it out, you can try to use perfect square trinomials. Perfect square trinomial is this one. A square plus 2ab plus b square equal to a plus b square, and a square minus 2ab plus b squared. If polynomial has three terms, we can try to use AC method or perfect square trinomial. These two formulas, they are called perfect square trinomials. Number 4. If the polynomial has four terms, if a polynomial has four or more terms, but for this class, all we can see is at most four terms. But in general, when polynomial has four or more terms, try to factor by grouping. When a polynomial has four or more terms, try to factor by grouping. But for this class, the most we see is four terms. We won't see more than four terms. But for all your future class, when you see four or more terms, we try to factor by groupings. Now, let's look at the following examples. Factor completely. Factor completely means we may take multiple steps for factoring. First one, 42x to the power 3 plus 45x squared y minus 27xy squared. So when you see a problem, first step, if possible, always try to take out common factors. When you try to factor in the first step, always try to take out common factor if possible. Always try to take out common factor. Look at 42, 45, 27. Do they have any common factor? So 42, 45, 27, 3 is the common factor. 3 divides all 3 numbers. 3 is the common factor. Is there any common letters? It looks like letter X is common. If I pull out X, I choose the lowest power. We have power 3, power 2, power 1. Lowest power is power 1. So 3x is the common factor. If I pull out 3x, what's left here? 42 divided by 3 is 14. X to the power 3 means there's 3x. If I pull out one of them, there are 2 more left here. Second term, 45 divided by 3 is 15. S squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Letter y stays the same. Next. 27 divided by 3 is 9. There's only one x. If I pull out x, there's no more x. Since I only pull out x, y squared stays the same. Now when we see 3 terms, we can try to use AC method. When we see 3 terms, we can try to use AC method. Take first times last. Positive 14 times negative 9. Positive 14 times negative 9 is negative 126. Positive 14 times negative 9. 9 times 4 is 36. Carry 3 over. 9 times 1 is 10. 9 times 1 is 9. 9 plus 3 is 12. Write down 2, carry 1 over. So I got 126. 14 times 9. 14 times negative 9 is negative 126. Now I try to find 2 numbers that they multiply to be 126. Add to be 15. I try to find 2 numbers that they multiply to be 126. Add to be 15. This number is big. Let's write down all possibilities. 126, I can write it as 1 times 126. 2 times 63. 3 times 42. 6 times 21. 7 times 18. And 9 times 14. That's all possibilities. That's all possibility for 126. Now I try to find 2 numbers that they multiply, they add to be 15. They multiply to be negative 126. They add to be 15. You can try. Try to add and subtract. See which pair give you 15. Try to add and subtract. Here we see that 21 minus 6 is 15. So I can try to use this pair here. 6 and 21. Since I try to obtain positive 15, I can try negative 6 positive 21. Negative 6 plus positive 21 is positive 15. And negative 6 times positive 21 is negative 126. This pair works. So I try to rewrite the middle term, replace the middle term with these 2 terms, using these 2 numbers. I leave the first term the same. I try to replace the middle term with these 2 terms. Minus 6 sy plus 21 sy minus 9y squared. I replace the middle term with negative 6 and 21 with the same variables. Then we have 4 terms. We can factor by grouping. When there are 4 terms, we can try to factor by grouping. For the first 2 terms, take out the common factor. For 14 and 6, common factor is 2. Common letter is x. And choose a lower power for x. X squared and x, lower power is power 1. So 2x is the common factor. Now, what's left? If I pull out 2x, what's left here? 14 divided by 2 is 7. S squared means there are 2x. If I pull out one of them, there's one more left here. Second term, 6 divided by 2 is 3. If I pull out x, there's only one x. If I pull out x, there's no more x. But since I only pull out x, y stays there. That's in the first half. Second half, 21 and 9. Take out common factor for 21 and 9, which is 3. Common variable is y. Common variable is y. If I pull out y, 3y is a common factor. 21 divided by 3 is 7. For the first term, if I only pull out y, there's only one y. If I only pull out y, there's no more y. But x stays the same. For the second term, 9 divided by 3 is 3. Y squared means there are two y's multiplied together. If I pull out one of the y, the other y stays there. So the common factor here is 7x minus 3y. Common factor is 7x minus 3y. If I pull out 7x minus 3y, what's left is 2x plus 3y. If I pull out 7x minus 3y, what's left is 2x plus 3y. That's the answer, but don't forget 3x in the front. Don't forget 3x in the front. Bring it down. That's the final answer. This is the final answer. So sometimes for factoring, it takes multiple steps. Next, 60p to the power of 3 plus 28 p squared q minus 16 p q squared. So when you see a problem, for factoring, when you see a problem, we always try to take out common factor first, if possible. Always try to take out common factor first, if possible. So look at 60, 28, 16. Is there any common factor? 60, 28, 16. It looks like the greatest common factor is 4. 4 is the largest number that divides all three numbers. And common letter is P. Common letter is P. For letter P, we choose the lowest power. We have power 3, power 2, power 1. Lowest power is power 1. So pull out 4p. If I pull out 4p, 60 divided by 4 is 15. P cubed means there are 3 p's multiplied together. If I pull out one of them, we have 2 more left here. Second term. 28 divided by 4 is 7. P squared means there are 2 p's. If I take out one of them, we have 1 more p, 1 p left. Since I only take out p, so q stays the same. Third term. 16 divided by 4 is 4. There's only 1 p. If I take out p, there's no p left. Since I only take out p, q squared stays the same. Now here we have a trinomial. When we see a trinomial, we can try to use AC method. A times c. 15 times negative 4 is negative 60. 15 times negative 4 is negative 60. We try to find two numbers that they multiply to be negative 60 and they add to be positive 7. We try to find two numbers that they multiply to be negative 60 and they add to be positive 7. 60 is a big number. Let's write down all possibilities first. 60 can be written as 1 times 60, or 2 times 30, or 3 times 20, or 4 times 15, or 5 times 12, or 6 times 10. That's all possibilities for 60. That's all possibilities for 60. Now, we try to find out which pair add and subtract to be 7. Which pair, when I add and subtract, I can get 7. I try to find out which pair, when I add and subtract, I can get 7. Here, it looks like 12 minus 5 is 7. 12 minus 5 is 7. Let's try 5 and 12. I try to make positive 7 here, so I can try negative 5, positive 12. Negative 5 plus positive 12 is positive 7. Negative 5 times positive 12 is negative 60. So negative 5 and positive 12 works. Now I try to rewrite the middle term using these two numbers. I leave first term the same. Replace the middle term with these two terms with same variables. You can try minus 5 PQ plus 12 PQ. Leave the last term the same. Now we have four terms. When there are four terms, we can try to factor by grouping. For the first half, take out common factor. For 15 and 5, common factor is 5. That's the largest number that divides both numbers. Common letter is P. For letter P, choose a lower power. Lower power is power 1. If I take out 5P, 15 divided by 5 is 3. P squared means there are two P's multiplied together. If I pull out one of them, another one left here. Second term, 5 divided by 5 is 1. There's only one P. If I take out P, then no P left. Since I only take out P, Q stays the same. So you get 3P minus 1Q. And when the coefficient is 1, usually we don't write 1. 1Q is the same as Q. So I write 3P minus Q. For the second half, common factor between 12 and 4 is 4. That's the largest number that divides both 12 and 4. Then common letter is Q. If I pull out 4Q, for the first term, 12 divided by 4 is 3. Since I only take out Q, then P stays the same. Take out 1Q, then there's no Q left. Second term, 4 divided by 4 is 1. And there are two Q's. If I take out one of the Q's, we have 1 Q left. And we know that when the coefficient is 1, we can eliminate 1. 1Q is the same as Q. Then we can see that 3P minus Q is common factor. 3P minus Q is common factor. If I pull out 3P minus Q, what's left is 5P plus 4Q. And don't forget 4P in the front. That's the final answer. Next. Negative 24 x to the power 3 y squared minus 6x squared y cubed plus 18xy to the power 4. So when you try to factor a polynomial in the first step, always try to take out greatest common factor if possible. Always try to take out the greatest common factor. We have 24, 6, and 18. The greatest common factor is 6. That's the largest number that divides all three numbers. Then we try to find out common letters. S is common. For letter X, lowest power is power 1. Letter Y is common. For letter Y, the lowest power is power 2. So take out 6sy squared. But be very, very careful with one thing. If the first term is negative, we need to take out negative sign. If the first term is negative, we always need to take out the negative sign. So take out negative 6sy squared. First term, negative 24 divided by negative 6 is positive 4. There are 3x. If I pull out one of them, we have 2 more left. Y squared means there's only 2 y's. I take out 2 y's, then there's no y left. Second term, negative 6 divided by negative 6 is positive 1. There are 2x. If I take out one of them, we have 1 more x left. Y cubed means there are 3 y's. If I pull out 2 of them, there's one more left here. And for any term, if the coefficient is 1, we don't write 1. For any term, if the coefficient is 1, we don't write 1. So leave the answer as x times y. Last term. Positive 18 divided by negative 6 is negative 3. Positive 18 divided by negative 6 is negative 3. There's only 1x. If I pull out 1x, then there's no x left. Y to the power 4 means there are 4 y's multiplied together. If I pull out 2 of them, we have 2 more left here. Now we have 3 terms here. When there are 3 terms, we can try to use AC method. Take the first times the last. 4 times negative 3. That's negative 12. Can we find 2 numbers that may multiply to be negative 12 and then add to be positive 1? In the middle, if there's no coefficient, we assume coefficient is 1. Can we find 2 numbers that may multiply to be negative 12 and add to be 1? We can try, for 12, we can try 3 and 4. We want to multiply to be negative 12, add to be positive 1. So we can try negative 3 and positive 4. Negative 3 plus 4 is positive 1. Negative 3 times positive 4 is negative 12. So negative 3 and positive 4 works. This trinomial can be rewritten as 4x squared minus 3xy. We use the same variable. Plus 4xy. We use the same variable. Use these 2 numbers with the same variable in the middle. And last term stays the same. Now we have 4 terms. We can try to factor by grouping. Now we have 4 terms. Try to factor by grouping. For the first 2 terms, take out the common factor. For 4 and 3, the greatest common factor is 1. And x is a common variable. Power x. Pick the lowest power. For letter x, lowest power is power 1. Then, if I pull out 1x, what's left is 4 divided by 1 is 4. X squared means there are 2x. If I pull out one of them, we have 1 more left here. Second term, 3 divided by 1 is 3. There's only 1x. If I pull out x, there's no x left. But there's 1y here. Since I only pull out x, y stays the same. Then, for 1x, if the coefficient is 1, we don't write 1. For 1x, if the coefficient is 1, we don't write 1. So 1x is the same as x. That's the first half. For the second half, take out the common factor. For 4 and 3, the greatest common factor is 1. The common letter is y. If I pull out 1y, what's left here? 4 divided by 1 is 4. Since I only pull out y, x stays the same. Second term, 3 divided by 1 is 3. Y squared means there are 2 y's. If I pull out one of them, the other one stays there. Then we know 1y, when the coefficient is 1, 1y is the same as 1. Sorry, 1y is the same as y. 1y is the same as y. Now we can see that here. Common factor is 4x minus 3y. Common factor is 4x minus 3y. If I pull out 4x minus 3y, what's left is x plus y. If I pull out 4x minus 3y, what's left is x plus y. Then for the final answer, don't forget negative 6xy squared. This stays in front of the parentheses. Don't forget this. This stays in front of the parentheses. Don't forget the common factor. Negative 6xy squared. This stays in the front of the parentheses. And that's the final answer. Next. Negative 30 x to the power 4 y plus 35 s cubed y squared plus 15 x squared y cubed negative 30 x to the power 4 y plus 35 x cubed y squared plus 15 x squared y cubed. First step, we try to take out the greatest common factor. For 30, 35, and 15, the greatest common factor is 5. That's the largest number that divides all three numbers. Then common letter, here x is common. X is common. Pick the lowest power. For letter x, choose the lowest power. Lowest power is power 2. And letter y is also common. Lowest power for the letter y is power 1. And since the leading term is negative, we pull out negative sign. Since the leading term is negative, we must pull out negative sign. So pull out negative 5x squared y. So first term, negative 30 divided by negative 5 is positive 6. X to the power 4 means there are 4x multiplied together. If I pull out 2 of them, we have 2 more left. There's only one y. If I pull out y, then there's no y left in the first term. Second term, positive 35 divided by negative 5, it will be negative 7. Positive 35 divided by negative 5 is negative 7. X to the power 3 means there are 3x multiplied together. If I pull out 2 of them, there's one more x left here. Y squared means there are 2 y's multiplied together. If I pull out one of them, the other one left there. Third term, positive 15 divided by negative 5. Positive 15 divided by negative 5. That's negative 3. X squared means there are 2x multiplied together. If I pull out both x, there are no x left. Y to the power 3 means there are 3 y's multiplied together. If I pull out one of them, we have 2 more left. Now we have 3 terms. When we see 3 terms multiplied together, we can try to use the AC method. A times C, 6 times negative 3 is negative 18. Can we find two numbers that they multiply to be negative 18 and they add to be negative 7? For number 18, we can write down all possibilities. 18, we can write 1 times 18, 2 times 9, 3 times 6. That's the only possibility for 18. It looks like 9 minus 2 is 7. So let's try 2 and 9. We try to get negative 7 here. So we can try positive 2 and negative 9. Positive 2 plus negative 9 is negative 7. When we multiply, positive 2 times negative 9 is negative 18. So positive 2 and negative 9 works. Keep the first term the same. Keep the last term the same. Rewrite the middle term using these two numbers. We can write plus 2sy minus 9sy minus 3y squared. First term and last term stays the same. Rewrite the middle term using these two numbers. And the variables stays the same. In the middle, the variable stays the same. Now we have 4 terms. We can factor by grouping. When we have 4 terms, we can factor this by grouping. For the first half, 6x squared plus 2xy. Take out common factor. For 6 and 2, common factor is 2. Common letter is x. Common letter is x. If I pull out 2x, 6 divided by 2 is 3. X squared, for x squared means there are 2x multiplied together. If I pull out one of an x, what's left is the other x. Second term, 2 divided by 2 is 1. There's only one x. If I pull out x, there's no more x. Since I only pull out x, letter y stays there. We get 3x plus 1y. And when the coefficient is 1, when we're doing factoring, when the coefficient is 1, usually we don't write 1. So we have 1y equal to y. 1y is the same as y. Second half. Common factor between 9 and 3 is 3. And common letter is y. Common variable is y. For letter y, the lower power is 1. So I pull out 3y. Since the leading term is negative, I pull out negative sign. So I pull out negative 3y. First term, negative 9 divided by negative 3 is positive 3. That's only 1x. So I didn't take out x, I leave it later. There's only 1y. If I take out 1y, there's no y left. Second part, negative 3 divided by negative 3 is positive 1. Y squared means there are two y's multiplied together. If I pull out one of the y's, the other y stays there. And when coefficient is 1, 1y is the same as y. 1y is the same as y. 1y is the same as y. So we get 3x plus y, 3x plus y. That's the common factor. 3x plus y is the common factor. If I pull out the common factor 3x plus y, what's left is, if I pull out 3x plus y, what's left is 2x minus 3y. What's left is 2x minus 3y. Then don't forget negative 5x squared y in front of the parentheses. Don't forget negative 5x squared y in front of the parentheses. This is your final answer. This is your final answer. Next one. 5x to the power 4 minus 80y to the power 4. When we are doing factoring, first step, always take out the greatest common factor first. If possible, always take out the greatest common factor first. Here, for 5 and 80, you can see that 5 is the greatest common factor. If I pull out 5 divided by 5 is 1. X to the power 4 stays the same. 80 divided by 5 is 16. Y to the power 4 stays the same. And remember, when the coefficient is 1, we don't write 1. So keep as x to the power 4. Now we have two terms. When there are two terms, we can try to use difference of perfect squares. When there are two terms, we can try to use the formula difference of perfect squares. X to the power 4 can be written as x squared squared. 16 is 4 squared. Y to the power 4 is y squared squared. So 16 y to the power 4 can be rewritten as 4y squared squared. 16 is 4 squared. Then you match the formula here. X squared represents A, 4y squared represents B. So if I use the formula, I have x squared minus 4y plus 4y squared, A plus B, times x squared plus 4y squared times A minus B. That's x squared minus 4y squared. If you observe the formula again, we can see that x squared minus 4y squared, it matches the formula. It almost matches the formula again. X squared is x squared. 4 is 2 squared. Y squared is actually y times y. So I can write it as 2y squared. Now you match the formula again. X represents A, 2y represents B. So if I use the formula A plus B times A minus B, I have x plus 2y times x minus 2y. And then don't forget the first parentheses. X squared plus 4y. Don't forget number 5 in front of the parentheses. That's the final answer. This is the final answer to this problem. Next. (64) s to the power 4 minus 4t to the power 4. 64 s to the power 4 minus 4t to the power 4. First step, for factoring, first step, always try to take out the greatest common factor if possible. Always try to take out the greatest common factor first. So here, the greatest common factor for 64 and 4 is 4. That's the largest number that divides both numbers. Then 64 divided by 4 is 16. S to the power 4 stays the same. The second term, 4 divided by 4 is 1. T to the power 4 stays the same. And we know that when the coefficient is 1, 1 t to the power 4 is the same as t to the power 4. Usually we don't write 1 here. We write t to the power 4. Then we can see that 16 is a perfect square. S to the power 4 is s squared, t to the power 4 is t squared. Then imagine the formula of perfect square, difference of perfect square. 4s squared represents a, t squared represents b. If we use the formula, we have 4s squared minus t squared plus t squared. 4s squared minus t squared. Then we can see that the second half match this expression here. A squared minus b squared. 4 is 2 squared. S squared. T is t squared. Then imagine the formula again. We have 2s represent A, t represent B. So we have 2s plus t times 2s minus t. Bring the first parenthesis down. 4s squared plus t squared. Bring number 4 down. This is the final answer. 4 times this. That's the final answer. Next. Nine y minus 9c minus x squared y plus x squared c. When there are 4 terms, again, we try to take out greatest common factor if possible. We try to take out the greatest common factor. Now you see that in the last 2 terms there are no numbers, so there's no common factor for numbers. Do we see any common letters? There's no common letters. S is not here. S is not in the first 2 terms, so S is not common. There are no common factors. So if there's no common factor, we try to factor by grouping. When there are 4 terms, we try to factor by grouping. So I group the first 2 terms together, group the last 2 terms together. For the first 2 terms, I can take out a common factor 9. 9 is the greatest common factor. If I pull out 9, I have y minus c. If I pull out 9, I have y minus c. For the second half, s squared is the common factor. For the second half, s squared is the common factor. Since the leading term is negative, I pull out negative sign. So I pull out negative s squared. So for the first part, if I pull out negative s squared, what's left is letter y. For the second part, positive sign divided by negative sign is negative. If I pull out s squared, what's left is c. Then we can see that y minus c is common factor. Y minus c is common factor. If I pull out y minus c, what's left is 9 minus x squared. If I pull out y minus c, what's left is 9 minus s squared. Now my question is, are we done? Are we done with this problem? Are we done with this problem? Observe this term here. 9 minus x squared. 9 is a perfect square. S squared is a perfect square. So we still match the formula a squared minus b squared. I can write 9 as 3 squared minus x squared. So 3 represents a, x represents b. We have 3 plus x, 3 minus x, That's the formula. A plus B times A minus B. That's the formula. A plus B times A minus B. Then keep the first parenthesis the same. That's the final answer. That's the final answer. Next. X to the power 5 minus 2x to the power 4 plus 4x to the power 3 minus ax squared. So if there's common factor for factoring, if there's common factor, always take out a common factor first. If there's common factor, always take out a common factor first. So here, there's no common factor for numbers, but for letters, letter x is common. We pick the lowest power. We have 5, 4, 3, 2. Lowest power is power 2. If I pull out x squared, what's left is, in the first term, x to the power 5 means there are 5x multiplied together. If I pull out 2 of them, we have 3 more left. Second term, number 2 stays the same. X to the power 4 means there are 4x multiplied together. If I pull out 2 of them, we have 2 more left. Third term, number 4 stays the same. X to the power 3 means there are 3x multiplied together. If I pull out 2 of them, there's 1 more left. Last term, negative a stays the same. X squared means there are 2x multiplied together. If I pull out x squared, there's no x left. So now we have 4 terms. Now we have 4 terms here. When there are 4 terms, we can try to factor by grouping. When there are 4 terms, we can try to factor by grouping. For the first 2 terms, common factor is x squared. If I pull out x squared, we have x. X cubed means there are 3x multiplied together. If I pull out 2 of them, there's 1 more left here. For the second part, if I take out x squared, what's left is number 2. Next, 4x minus a. Common factor is 4. If I pull out 4, 4x divided by 4 is 1. X stays the same. Negative a divided by 4 is 2. Negative a divided by 4 is negative 2. And when the coefficient is 1, usually we don't write 1. 1x is the same as x. We have x minus 2 here. Now we can see that x minus 2 is the common factor. If I pull out x minus 2, what's left is x squared plus 4. Then don't forget x squared. Bring x squared down. Are we done? Is this the final answer? Can we factor x squared plus 4? x squared plus 4, does it match this formula? This formula has a squared minus b squared, but we have x squared plus 4. This is addition. This is addition. It doesn't match this formula here. It doesn't match this formula. So this is not factorable, and that's your final answer. Since x squared plus 4 is not factorable, that's the final answer. Don't forget this x squared. That's the final answer.